All right, thank you. So let's get started. Welcome to KUDH 2021. Good morning, good afternoon, or good evening, everyone. I'm So Miyagawa, an assistant professor in digital humanities at Kyoto University. Today, we have the second day of KUDH International Conference 2021, Digital Transformation in the Humanities at Kyoto University, but held online via Zoom. As we saw on the first day, digital humanities, DH, is an interdisciplinary research field that uses digital technology to preserve, exhibit, analyze, and educate about cultural resources and humanities materials. The innovative hub of interhumanities, the Graduate School of Letters, Kyoto University, is pleased to announce the holding of an international online conference with 3 DH researchers from Kyoto University and 7 international DH scholars from the Czech Republic, Germany, the United Kingdom, and the United States. The fields covered digital corpora, character encoding, and digital curation. The covered cultures include East Asia, Western Antiquity, Ancient Egypt, Ancient India, and Ancient Maya. All research presentations will be online. For those who can't make it, we will also provide recordings on YouTube. This image is Methodological Commons by Willard McCarthy and Harold Short. This is often used to explain the common ground of methodologies in digital humanities. Today's topic is character encoding and digital curation and archiving. So we seemingly cover linguistics, computer science, etc. for character encoding, and art history, material culture, archaeology, library science for digital archiving and curation. However, from the point of view of digital humanities, both have the methodological common ground. The methodologies such as annotation, automation, and visualization are shared with various disciplinary groups, including today's topics. When we dissect the methodology, we can see shared elements as the so-called scholarly primitives, which is basic functions common to scholarly activity across disciplines. John Unsworth listed scholarly primitives: discovering, annotating, comparing, referring, sampling, illustrating, and representing. We share the common methodological ground and scholarly primitives among various disciplinary fields using digital tools and methods. As such, digital humanities is a big cloud connecting various academic fields which were indifferent to each other in the past. This is one goal of DH, to connect and unite various disciplinary fields. This event is hosted by Kyoto University, Graduate School of Letters, Center for Studies of Cultural Heritage and Interhumanities, the Innovative Hub for Interhumanities. Professor Chigusa Kita is the director of our hub, our Innovative Hub for Interhumanities. Professor Kita, may I ask you to introduce our Innovative Hub?
Okay, thank you for joining the conference from all over the world. I will explain briefly about our Innovation Hub. It is a part of the Center for Studies and Cultural Heritage and the Interhumanities, which was established on April 2019 as a result of merger of 2 centers, one of which was the Center for Eurasian Cultural Studies, which has played a pivotal role in Inner Asian studies since 1966. And the other was the Center for Cultural Heritage Studies that has conducted numerous archaeological activities within the Kyoto University campus. The brand new center takes up the mission of integration of humanities, and our Innovation Hub has recently been designed for promotion and diffusion of the interdepartmental research activities and digital research methods within the Graduate School of Letters. Almost a year ago, we opened a position for an assistant professor with a command of digital humanities research technologies. So Miyagawa applied to it with a dream of organizing this kind of international conference. So's dream became our dream, and we are delighted to realize this conference today with prominent speakers and audience from all over the world and within Kyoto University through a hard work of a promising assistant professor. Thank you, So. Let's start the sessions of the day too.
Thank you so much, Professor Kita. Thank you so much, Igusa. Thank you so much for very kind words. So let's get started. Today, we have 3 talks in the first session, character encoding, and 2 sessions, two talks, sorry, 2 talks in the second session, digital archiving and curation. So we have talks by first Tomohiko Morioka about machine readable description of Chinese characters, then talk by Carlos Palangayol, the encoding of Mayan hieroglyphic writing, and talk by Mark and Nederhoff, Unicode control characters for ancient Egyptian. So we cover East Asia, classical Maya, and ancient Egypt. And then we have the second session, data archiving and curations, Kyoto, Leipzig, London, and Stellenbosch. The first talk will be by Chifumi Nishioka from Kyoto University Library, the development, collaborations, and evaluation of the Kyoto University Rare Materials Data Archive. And then finally, Francisca Neta from Saxon Academy of Sciences and Humanities Leipzig, current trends in data editions and curatorial practice, examples from Leipzig, London, and Stellenbosch. This will be, thank you so much for all the presenters to have your presentation today. I'm so grateful. We are so grateful to you. We have now 2 minutes left, but all right. Yeah, so this conference will be recorded, is now recorded, and we will send you the link to the recordings later. And we would like to put it online as our kind of video publication of our innovation hub. So please, please consider that. And okay, so we have 1 hour for each presentation, but the standard will be 40 minutes for talk and 20 minutes for Q&A. But dear presenters, please use your time as you wish, and it is very flexible. And you can do your presentation much shorter or a bit longer. But if you do it longer, the Q&A session will be shorter. But if you do it shorter, the Q&A session will be longer, or maybe we will have a pause. All right, we have now 16 participants. Thank you so much. We got over 200 registrations, over 190 registrations from all over the world, from the US, from Australia, from Europe, from Japan, etc., from China too. And most of them, I think they will watch the recordings later. But today, the session will be the very proper time in Europe. Maybe the first talk is a bit earlier for European people, but probably we will have much more participants than the first day. Okay. All right, so let's get started. Let's start the first talk. The first talk will be given by Professor Tomohiko Morioka from Kyoto University. He is a assistant professor of Institute for Research in Humanities, Center for Informatics in East Asian Studies, and he's principal investigator of the CHISE project for encoding Chinese characters. Okay, I will stop my sharing, and Professor Morioka, please go ahead.
Thank you. I will start my talk.
Sorry, it is now, we can see the presenter's note. Is it all right?
Oh, okay. My English is very terrible, so but unfortunately, I can't prepare all of the talk. So anyway, please ignore our, anyway, you can read it.
Okay, thank you.
Today I am talking about overview and background of CHISE. And before talking about CHISE, I would like to talk about the background of my project. Anyway, this is a Tonko Shahon in Japanese and Dunfan manuscript. And it was written in early Tang style kaishu. Many characters are almost the same as modern glyphs, but some characters are written in different glyphs. For example, these two characters. Are they same character? And this character is similar to this character, but something different. Anyway, if we were digitize this text, we would have to choose character code. It means that we have to think about sameness or identity of characters. Today, I would like to talk about the CHISE character ontology, and this is the background of its design. And before talking about today's session, I would like to my self-introduction. One major work is they are major work of my studies. One is the CHISE project. This is a website, and that is today's major topics. And other works that this is a bibliography of Oriental studies on the web. That is a database for Chinese studies papers or books, and morphological analyzer for classical Chinese. That is a collaboration work with Professor Yasuoka. And CHISE project, CHISE is an acronym of Character Information Service Environment. It's an open source research and development project, to realize text processing environment that can freely use character encoding or character definition by users. Any user can define character definition. Any user can define character, and CHISE is CHISE provides character definition mechanism. It is based on character ontology. And there are some web services about CHISE. One is a CHISE IDS database, CHISE IDS find. To put into the component of character, then slow. Then characters are listed in this Chinese characters, including specified components, are displayed. And click the link, detailed information are displayed. this screen is a Wiki OS, and there are Sparkle endpoint for RDF dataset. Before explaining Chise, I'd like to talk about Chinese characters as design background. Chinese characters are used to write to Chinese and Japanese, and historically used in Korean and Vietnamese or some other East Asian languages. But originally it was a script for classical Chinese. So basic characteristic is based on it. As phonetic script, Chinese characters basically syllabaries. In other words, each character corresponds to a morpheme, classical Chinese morpheme. And other characteristic is productivity. Many Chinese complex characters composed of multiple components. For example, this character means wood, consists of 2 trees, left to right. And this character, cloud, consists of rain and these phonetic parts. And this character also consists of these 2 components. And other characteristic is Chinese character has many characters, at least 1,000 for daily use characters, and over 10,000 characters are found in historical and modern characters used in various times and regions. Currently, Unicode encodes about 90,000 characters and will include 100,000 characters. And they have many variant forms. For example, this is a various glyph images of this character. Chinese character be written in various forms. So we usually use this model to think about glyph variations. The first layer is conceptual character. It consists of a morpheme, and of course, morpheme in classical Chinese. And the third layer is a glyph. And Unicode unifies some glyphs, some similar glyphs into one abstract character. So abstract character layer is also required. And unification to unify some glyphs, some similar glyphs to one abstract character, unification rules are used. And before applying unification rules, glyph design differences are abstracted before applying the unification rules. This is a sample of glyph design differences in Japanese Joyo Kanji Hyo. Usually, it is basically represent differences between handwriting and printing forms. And historically, print forms there are some different glyph designs. However, anyway, these glyph designs are very similar. So it may be trivial, but sometimes boundary between glyph and glyph difference and glyph design difference are very ambiguous. Perhaps these two glyphs are very similar, and maybe they are the difference between two glyphs are glyph differences. But these glyphs are quite different. It is also, but sometimes dot and vertical line are different character. So, and in this case, very similar, but the strokes are different. And sometimes existence of dot or nothing is very similar and maybe same character, but in this case, they are different characters. Of course, these three characters are also different characters. Anyway, current coded character model, usually now we are using character code such as Unicode or JSX 0208. They are based on coded character model. In this model, each character is represented by an integer. To implement it, semantics of characters are defined in a standard of coded character set, where only the syntax is defined. It is assumed that you know in advance whether any two characters are same or different, or an exhaustive set of all the characters needed to write any text. So, but basically, this is impossible. So we need gaiji, private used characters. Anyway, I'm talking about basic concept of Chise. In this mode, in Chise, each character is an object of object-oriented languages. So implementations such as internal character codes or internal data representations are hidden. Instead of it, but in Chise, internal character codes are implementation of character representations. Users should not use character code, internal character code. Instead of it, users should use Chise provides some interfaces to create character operations. This is a basic model of characters in Chise named Chao model. In Chao model, Chao model is a character representation model based on set of features. Each character consists of a set of features. So we can use set operation of character features. In other words, we can use different sameness or identities to create various real-world characters. Object representation of Chise. Chise uses Chao model to implement character object. We usually use association list or anyway set of features And any character object can be represented by a set of pairs of key and values. In JSON, object can be used to this representation. But Chise uses S expression of Lisp natively, but supports RDF and other formats using mapping rules. In RDF, a feature is represented by a triple. Subject is character, and the predicate is feature predicate, and object is feature value. And some RDF predicates are defined. And there are various features are used in Chise character ontology. And the first type is radical or stroke or some same atomic type. And the second is relation features. Relation features is a feature to represent relations between characters. This is a triple between character A to character B with relation rel. In an object, character A has a relation feature name is to rel, and the value is B, character B. And B has a relation feature from rel. They are reverse to relation features. And anyway, the value is A. Relation feature can be used to variant relations, interscript relations, unification relation, or etc. And the second important feature is CCS features. Chise supports various coded character set as a mechanism of feature. Chise has a concept of granularity of character objects coverage. So each CCS feature consists of prefix of granularity and name of features, and optionally domain are added. For example, this prefix is a super abstract character or character class, and the second part is name of CCS, daijiten. So it means that character classification in daijiten, and this is a 1990 version of GCX0208. It's abstract character encoded by 1990 version of GCX0208. Anyway, this is a glyph, abstract glyph, CNS abstract glyph encoded by UCS, and that is a 文字情報基盤図 abstract glyph image. And this is a glyph image of 改正設計. Anyway, we would like to, we can represent various granularity and variants based on coded character set. And Chise provides feature of domain. This mechanism is sometimes we have to represent various usage or purpose or applications or source interpretation or theories, etc. And it sometimes one data is depended on such kind of context. Perhaps it is, if you know TI, app tag is very similar. Anyway, CISE provides mechanisms to multiple feature values depending on such kind of context. Domain feature consists to use a domain. CISE feature name of CISE consists of base name and domain specifier. And the domain specifier can add subdomain or sub-subdomain, etc. Anyway, domain specifier can be nested. For example, this is denotational at usage. This is a future value. The future value is a character class based on morpheme. And second is formed at Showan Shao Fuben. This is a Fukai's description in Showan Jichan. And one of the most important features is structural description. Many Chinese characters are complex characters composed of multiple components. This image is a Showan jersey. This is one of the oldest Chinese character dictionary based on radical classification. And each entry is head is a small cell glyph, and this description is this character is an ancient form of this character child, and this character is consists of these two parts. Perhaps if we teach the knowledge to a computer, so we can currently use it, we can describe such kind of information to use IDS format. This is an operator and component. This character is a modern form of this character, and this character is a modern form of this character. So anyway, in Unicode, there is a specification about ideographic description sequence and special characters to describe the composition of Chinese character components named IDC. Anyway, we can describe composition of components using IDC. For example, this is a village, and this IDC means second and third component are combined and arranged left to right. And this is a vertically composition operator. And three it takes 3 components and arranged vertically. And also, IDS can also be used as a component. So nested form allowed. By the way, for some Chinese characters, there is an ambiguity in the structure analysis results. For example, this character can be described as this IDS or this IDS. And this character is also can be described as this structure or this structure. So anyway, there are multiple decomposition strategies and structure description policies. Most easy way is apparent structure method or apparent component view. In this view, components are visible objects. In these cases, it is very easy and maybe clear. However, in this character, if it perhaps in apparent structure, as apparent structure, this IDS, this is a apparent IDS. In this IDS, is this substructure component. And the second way is a functional approach. In this view, component is an interface to associate phonetic and or semantic values and shapes. In this view, this structure is not a component. However, if you don't know the target character, you will not know the functional components. Maybe it is a goal. And the third view is glyph design variation of component. Component is a unit to describe glyph variations of Chinese characters. For example, they are glyph. These 3 glyphs are variation of one abstract character, and the difference is this upper component. It means wing, but they have some different component design. If an abstract component, abstract wing is defined as a set of these glyphs, it is possible to describe abstract character. This abstract character is using abstract component. To apply this view, Chise uses multiple granularity Hanzi structure model. It is a abstract character of flower, and it consists of 2 abstract components. And this abstract component has some abstract glyphs and detailed glyphs. And this component is also correspond to 2 different glyphs. And this is also other unified glyph object and glyph image object. And this glyph consists of glyph granularity component. Anyway, character unification, character level unification and component level unification corresponds. And this method is also can be applied to interscript mapping. This is a modern component of tree, and this is a small cell component of tree. They corresponds. And this is a IDS for modern characters. And this is IDS of this modern character means wood. And it uses modern component. This modern character corresponds to small cell glyph. And this small cell character has IDS, a small cell IDS, and this small cell IDS includes this small cell component. Anyway, if we know the knowledge about modern IDS data and character relation between modern to component relation between modern to small cells, so we can get this small cell IDS from modern IDS. And other view is description based on productivity. Components are objects that combine them to create Chinese characters. So components that can produce many Chinese characters have high componentness. If a component is included in only one Chinese character, it is meaningless to regard it as a component. Perhaps in that case, inappropriate decomposition are described. Anyway, mechanical analysis is possible using the Chise IDS database. In case of this character, this component has a high productivity. There are a lot of characters including this component, but only these characters are including this substructure. And basically, they are same character. Other example is this character flag. Anyway, this component has high componentness and high productivity, and this component is not so high. And basically, component and this graph is productivity of components. This X line is log of rank, and this Y is Y is number of characters, including this including component, and this distribution seems to follow the Zipf's law. And pipeline is a data set based on functional structure, and green line is basically designed as apparent structure, but they basically have similar distribution. So anyway, in many cases, description based on apparent structure and description based on functional structure have equivalent information. So we can write rewriting rules such as this structure can be converted to this structure or this rule. This structure is converted to this character. And term rewriting system, TRS, can also normalize glyph variants with unification rules. And Chise have some, Chise integrates some text-to-image databases. One is HND, Hanzi Normative Glyphs dataset, including Daijiten dataset. And second is Shoen images in our laboratory. And third is Oracle characters. It is underdeveloped. HNZ is the most important dataset of integrated to Chise. It is a Kaishu glyph corpus of Chinese characters from 63 manuscripts, including stone-laving images and woodblock printed books. It is based on Ishizuka Register of Chinese Character Standards of Writing. And this is a URL of this dataset. You can get original card images and cryptoglyphs. あ、違った。Anyway, if you are interested in, please check it. And HNZ dataset has two searching services. One is this site. HNZ simple search service. Input to a character. あ、そうだ。Then historical glyph examples are displayed. And click this information. Original card images are displayed. And for some resources, some sources, original text to full text images are linked. Okay. これか。This is a text images in Gallica. And this is a loving images in our laboratory. And second service is to say IDS HNG search. In this service, as the same as IDS find, user can input multiple components and search. Then you get the result like IDS find. And other example is Showen database. Chise provides IDS for Showen small cells. This is a relation feature for Showen corresponding Showen character. And this object have a handy structure for small cell. It is also, it has a link to two full text images. And you can use IDS find service using small cell component. Then you get small cell characters, including this small cell component child. Then perhaps that is the time. Conclusion. Chise character information service environment is a character process system based on character ontology. It is not dependent on general character codes such as UCS. To make the computer understand various knowledge about characters. And it is a character to implement this feature, character provides character processing mechanism based on machine readable knowledge. So Chise works as a meta system of UCS or other private character set to describe characters and their knowledges. So anyway, this is a I stopped my my presentation, and sorry for my terrible English. Thank you.
Oh, thank you so much, Professor Morioka, for a fascinating talk. Yeah, I was very amazed by the, your database and your service, and also the strategy to pick up components by frequency. Thank you so much. Yeah, so question and answer session. If you have a question, please unmute yourself and ask Professor Morioka. If we were thinking about question, I want to ask Professor Morioka about one question. So your system is not dependent on the Unicode, but will you have a kind of proposal to Unicode Consortium to include some kind of what is that, control characters to enable more complex and elaborate, combinations of the components?
Perhaps I should do it. And in fact, I use some additional IDC. For example, I start sharing. I say uses some private additional IDCs. One is an abstract IDC. It unifies two IDC, left to right, and this covering IDC. And second type is missing IDC. This combination requires to represent ancient or modern some functional IDS, and this is also in original IDC. This IDC is an overlapped IDC, and it means that only overlap, and how it cannot explain how two components are overlapped. So say classifies some overlapped IDS to more concrete IDCs, such as this left to right to overlapping, or up to left to overlapping, or bottom to up overlapping. Anyway, some people proposed new IDCs. Perhaps I should help them.
I see. Yeah, I think the number of IDCs is kind of it's indefinite, right? It's
in Chise.
Yeah. No. I mean the existing.
Existence. Existence is currently UCSC includes this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 IDCs. And maybe 2 new IDCs will be added.
Ah, okay.
Mm.
I see. Right. Thank you so much. Does anyone have questions and remarks? It is okay with a very basic question or just clarification question? Nobody? Maybe may I ask the second question? So your database and service is very comprehensive and very massive. How the other researchers how many researchers do use your databases? Especially, I'm very curious about the researchers in China. Do they use your database and service for their research practically?
I don't know the detail, but Chisei, I heard Chisei is used in IRZ. That is a group to develop UCS unified ideographs of Unicode, and perhaps Nagasaki-san's group and other scholars to digitize text databases or classify private characters. Say, well, they use this to find their private characters, and usually they find UCS code point correspond to their private characters using CIDs find, or they find lacks of the UCS.
I see. Thank you so much. And what is the most complex Chinese characters you coded in Chise? I'm very curious about that.
It is depends on it depends. One is most but sometimes there are very curious, strange Chinese characters include kana component and Chinese character component, or handwriting style characters.
Oh, okay.
Maybe in Japan, there are various strange glyphs used in proper names, or and similar example is found in Vietnamese. Currently, UCS unified ideographs includes Vietnamese characters.
You mean Trinomo?
So yes.
Ah, I see. It's very complex, right?
Yeah, and this is basically based on not based on kaishu forms. So different glyph design are used. So we have to normalize component design to encode as Unicode.
I see.
And also, if we would like to encode ancient Chinese characters such as Oracle-born characters or currently some Shinkan, anyway, old Chinese characters, we have to, there are some なんていうか、自由度が高いっていうのか。
Very flexible or
Yeah,
I don't know, very variable.
Yeah. And we don't understand some characters. So, つまり、そのまだ意味がよく分かっていない文字。
So we have characters we do not know that it's their meanings.
And その部品の組み合わせ方自体を理解できていない。
I see. So we have very many unknown characters of the combination or structure of which are pretty unknown, pretty complex and too complex, and we cannot figure out. I see.
Anyway, this is a list of productivity. Upper is functional. This is some strange formula to detect accuracy by and upper is functional accuracy and lower is apparent accuracy. This component, it means that this component has high accuracy and this component is low accuracy. And I calculate basically all of the Chinese characters included in CIDS database. Perhaps there are some bugs, but basically functional structure has high accuracy.
I see. It's very nice that you also have the data of accuracy in your database. Thank you. That's very, yeah, I think it's also very nice for the study of the Chinese characters itself. Do you have any questions or remarks, the audience? Or just clarification questions? We have, sorry, we have 2 minutes. No question. Do you, Morioka Sensei, do you have any remarks to conclude?
Okay. One is data resources. Say program and data of Chise is basically basically in this GitLab site, GitLab Chise org. That is a source of Git repository of Chise IDS database. And there is a mirror in GitHub. Perhaps if you would like to use this data set, please check it.
It's wonderful that you provide the data set to us, and yeah, we can also reuse it for our future project in the yeah, for the Chinese characters and so on, also Chinese philology, I think. Yeah, so thank you so much, Professor Morioka, for a fascinating talk. Thank you so much.
Thank you. Sorry for my very terrible presentation.
No, it was very great presentation. Thank you.
Right. Bye.
All right, so we at 17 o'clock in Japan time. So we have the second talk today on classical Maya character encoding. Our speaker is Carlos Palancayor from the University of Bonn. He was working for encoding Mayan hieroglyphs for a long time, and he had various projects on that. And today he will talk about the, the title is the encoding of Mayan hieroglyphic writing. So yeah, please, the floor is yours, Carlos. Thank you so much for joining.
Thank you so much to So Miyagawa and the Kyoto University in Digital Humanities Department for this kind of invitation. And I would like to present the encoding of Maya hieroglyphics, hieroglyphic writing. Let me share my screen so that you can see the PowerPoint. Okay, let's see. All right, hopefully that's working now. So you are able to see the presentation, right?
Yes, it's perfect.
Okay, great. So I'm going to talk about the encoding of Mayan hieroglyphic writing and the steps we've been taking. Well, in my case, since a long time ago, I started applying digital humanities tools and methods to Maya hieroglyphic decipherment, essentially since 2006. And then I've continued, as So kindly mentioned, through a number of different projects. So I'm gonna walk you through the some of the major steps that we have taken towards this same, but also I'm gonna discuss a few of the challenges encountered. So first of all, to provide a little bit of context, the Maya hieroglyphic writing belongs to a set of Mesoamerican cultures. The Maya were not alone in Middle America or Mesoamerica, but they were neighbors to a number of other cultures, some of them quite advanced cultures, which also had hieroglyphic writing. Just to mention a few of them, you can see here a map of Mexico and Guatemala and Central America with some of the main cultures involved. So the Maya area is being here marked in red here, and you can see the corresponding hieroglyph for one of the main gods of the Maya. That's the rain god, Chak, and the equivalent forms for all the other cultures. So here in purple, we have the Mixtec in the area of the valley of Oaxaca. So they also had a hieroglyph for the rain god, which looked like this. Obviously, the names were different according to the languages they were using in all these regions. But we also had the powerful culture of Teotihuacan here in central Mexico, which expanded all the way to Central America and even had important contacts with North America and so on. But the Maya were mostly in contact with the culture highlighted here in green, the Mijezoquean culture, which had a very similar writing system to that on the Maya, except Mihesokian has not been deciphered yet. And Maya is at an advanced stage of decipherment. Now, Maya inscriptions come in a number of different media and formats. We have here a map of the Maya area highlighting some of the main Maya capitals like Chichen Itza in the north, Calakmul, Tikal. Then on the west, we have Palenque and Copan in the south on what is now Honduras. And the Maya expressed themselves in hieroglyphic writing and quite sophisticated iconography as well on architectural items of construction like lintels or columns and jambs, but they also developed hieroglyphic books, which we call codices. I'm going to get to the codices in a second. And they also had these quite refined polychrome ceramics, similar to the Greek vase decoration style that were popular in the Mediterranean, showing pictures of deities and sometimes really long hieroglyphic texts explaining mythical episodes and so on. Here's an example from Copan. And this is a stela, which was one of the preferred ways of what we call public monumental sculpture. Now, about the codices, we have several lines of data to show us how they were produced. And at some point, there were surely thousands of these books in existence in the Maya region. But now we have only 3 of them left. Most of them were lost by natural conditions and cultural conditions, but several of them were burned by European religious authorities or Spanish clerics and bishops and so on that wanted to essentially ban Maya religion. It was prohibited to practice Maya religion after the time the Europeans arrived into what is now Mexico and Guatemala. So a lot of these quite refined books were lost in the process, and there were different stages in their production. You can see here on this artistic reconstruction that they were meant to be folded as an accordion, in accordion style, what we call leporello style. So they were a bit different than Europeans' books, but not so different to some manuscripts that we know from Asia, like in China and Japan and other parts. We do see manuscripts fold or screen fold manuscripts in this way. And they would go through different stages of production until they they arrive into the hands of a master scribe or a religious specialist. He was also a priest who would paint them. Here we have examples of pages from the 3 extant codices. One of them is at the library at Dresden in Germany. The other one is in Madrid in Spain. We call them the Madrid Codex. And the third one is in Paris, is known as the Paris Codex. Now, this is a close-up of one of the pages from the Dresden Codex, what we call the Venus table. And you can see that there's a sophisticated interplay between text and image here, or what we call visual and textual discourse. So the text passage here relates to the god that we see here, sort of a blindfold god. I'm going to talk about more of about the codices later. Now, Maya hieroglyphic writing came to be deciphered in a different way than Egyptian hieroglyphs, for instance. Most of you or all of you know the history of the Rosetta Stone that was discovered in Egypt by the military campaigns of Napoleon Bonaparte. And it was brought originally back to France, but then Britain recovered the Rosetta Stone, and it's nowadays in the British Museum after defeating the French in a famous battle. Now, because of the Rosetta Stone contains what we call a biscript. It's actually 3 different scripts together. Jean-François Champollion was able to match what are called royal cartouches in ancient Egyptian hieroglyphs with similar names written in Demotic or Greek. So as shown here. So by matching these names, he was able to work his way towards how the ancient hieroglyphic Egyptian worked. In the case of Maya, we didn't have a Rosetta Stone. The closest thing we had was an so-called alphabet by Friar Diego de Landa. But as you can see here, it's quite incomplete. And to further complicate matters, it was not understood how it worked for a long time, because a lot of earlier scholars thought these were letters. In other words, that this writing system was alphabetic, depicting letters equivalent to the Latin alphabet. Now, it took a long time to determine that these were actually phonetic sounds. They were syllables, not so different than the katakana system in Japan. I'm going to explain a little bit more of the workings, but this was elucidated by a Ukrainian scholar working inside what was then part of the Soviet Union, but he was born in Ukraine, Yuri Knorosov. Here we see a picture of him at his office in Leningrad, which is now, as you know, St. Petersburg. And he was able to determine much of the phonetic workings of the script. Just to provide a couple of examples, in the syllabary, or the so-called syllabary by Landa that we were looking at, 2 signs appear which resemble, well, the signs here, the sign for Q appears at the Landa manuscript, but the second sign was not known, but this was accompanied by a picture of a turkey. This is a turkey here. Then Knorosov was able to determine, okay, the initial phonetic sound is Q. So he went to look into Mayan dictionaries. He was assuming that the language being recorded was Yucatec Maya, because the codices or hieroglyphic books were found or were thought to belong to Yucatan. So he found, he searched for entries for Turkey in the dictionaries and found that there was a very widespread word for Turkey in Maya. Yucatec Maya was pronounced Kuts. So he inferred, and it turned out he was correct, that this sign, which was unknown, would be providing the sound ts, ts, to complete kuts, kuts. And then he applied this knowledge to another scene of the Dresden Codex, where the same sign appears in first position, but this time above the picture of a dog. This is a dog here in Mesoamerican style. And the second sign was unknown, was undeciphered. So he repeated his methodology and searched for dictionary entries for words for dog in Yucatec Maya, and he found that tzul was a word for dog. So this helped him to realize, okay, the sign that he had, what we call a test decipherment or a hypothesis about as functioning with a value of 2 was here complemented by a second sign, which he inferred could provide the consonant l to form tzul, which is the word for dog. So this is what the methodology that Yuri Knorosov was following, and this proved to be correct for a number of decipherments. As we can see here, that these two signs form the word kutsu, written together to form a single word kuts. And the second sign here is used, the second sign here is used as a first sign here to provide the word for tsu, lu, to form the word for dog as tool. Further advancements were made by figures like Heinrich Berlin, working in Mexico, who came up with his theory of the emblem glyphs, and he correctly hypothesized that these sort of glyphs, which had sort of a constant structure where the first and the second elements were consistent across all of them, he inferred that these might be the names of the ancient Maya cities or political entities. And cities like Calakmul or Tikal, Copan or Palenque had their own emblem glyphs. And working in the mid-20th century, Tatiana Proskuryakov, a scholar of Russian origins, was able to demonstrate that Mayan inscriptions indeed had historical information, like the biographies of kings and the births, the life cycles, birth, death, and so on. And what he inferred, possibly accession. So they were, in her view, the Maya were recording all these dates when kings were born, when they acceded into power, and when they died. And time proved her correct in many ways. Now, a few decades later, there were also major advancements in hieroglyphic documentation, thanks to scholars like Ian Graham, who went to a large number of sites in Guatemala and Mexico to make new documentations with very high standards. And when studying ancient writing systems, one critical part for scholars is to have accurate documentation. And the standards started to become a lot higher thanks to the collaboration of, the contributions of Ian Graham. Here we see an example of the new and more rigorous, higher quality documentation that Ian Graham was starting to produce with very high standards, from inscriptions from Yaxchilan or Naranjo here. And in parallel, a number of casual meetings started to take place with scholars like Peter Matthews, Linda Shealy. We see here David Stewart, Floyd Lounsbury, John Josteson, back in the 70s, in the 1970s. And this series of casual meetings resulted in great leaps in hieroglyphic decipherment. I had the privilege of working together with Ian Graham at the site of Yaxchilan. And here we are working on documenting one of the inscriptions. You can see this is a stela from Yaxchilan, and it has a column of hieroglyphs here. So we started to implement our own methods for documenting Maya inscriptions using digital humanities technologies like photogrammetry, RTI, or reflectance transformation imaging, and so on. So here we see an example of my work in the site of Huachactún and Manantial in Guatemala using photogrammetry. Here we were quite excited because of the discovery of these stone monuments. It's actually a stela. Here is the project director, Milan Kovac from the University of Bratislava. I was working with him in this project. And here is the documentation by photogrammetry, which allows us to, as you know, to manipulate the object on a virtual environment so that we can retrieve a higher amount of information from the object. And this is very useful for decipherment. These are some examples of the new documentation techniques that we were starting to implement with high quality imaging. And then we were able to generate vectorial drawings tracing directly on top of the images with these digital tablets and so on, to trying to produce more accurate drawings of Maya inscriptions. Now, all this work, how does all this work translates into decipherment and into the efforts that we are doing? Well, we decided that one path to go was Mayan encoding, because working on encoding would allow us to do a number of things. First of all, it would allow scholars to use a common set of electronic characters that could be shared online, for instance, through an email or through digital publications. They could also be used to create digital repositories. And it would also allow to create text and mix ancient hieroglyphs with modern Latin text or modern Chinese characters. We could use all of them together on a single page, for instance, on Microsoft Word or on PDF documents. So they wouldn't be images, because images are not typically machine readable. There are ways, of course, to do machine vision and automatic vision, but this takes a number of steps further. What we were trying to achieve was using a set of characters which could be machine recognizable. We could apply OCR, or optical character recognition, and so on. So here is an example of the Maya syllabary and how we were completing some of the slots in the syllabary with these electronic characters that I'm marking here in red, some of them, and others in blue. And in this, we were trying to to build upon previous efforts to build hieroglyphic catalogs, like the one by Eric Thompson, or the outline dictionary of Maya glyphs by William Gates that you see here. And our early efforts focus on creating a glyphary tool. This is an early version of it, but here I was collecting all the new characters that we were producing, and I was cross-referencing all these characters to all the previous existing catalogs, because all these previous catalogs had codes. Like, for instance, the Thomson catalog had its own codes that started with a prefix like T533 and so on. And then there was the Russian catalog by Yuri Knorosov, the scholar I was mentioning from Ukraine. And he also had his own catalog. So we were matching all these different codes, and we were filling in the gaps because we found a number of signs that hadn't been properly cataloged yet. And we started coming up with our new codes and our own taxonomy to classify these hieroglyphs. Here I'm showing an example of how we were using a numeric sort of sign identification at first. So this was sign 12 or 12310, and afterwards I assigned more alphanumeric codes and hexadecimal codes, like what we call code points. But this was an early version, and this allowed me to create a full repertoire of all the hieroglyphs used in the Maya codices or the Maya hieroglyphic books. This is the glyphary that I put together based on the method I was explaining before. And here you can see a close-up showing the taxonomy that I devised for this, which was based on previous catalogs for Egyptian hieroglyphs, like the Gardiner, the grammar made by Alan Gardiner, or the Manuel de KUDH for Egyptian. So I built a categorization using, for instance, different profile heads for skull signs, underworldly gods or deities, flayed entities. Some of them were more human-looking entities, and others were more supernatural-looking entities. And we have also categories for animals based whether they are mammals or reptiles, or marine life like fish or mollusks and so on. And we also have categories like hand signs, architectural items or tools, implements, weapons, and so on. Here you can see an example of hand signs used by the Maya. So based on this new taxonomy, this new categorization, I was able to put together a glyphary incorporating all the sign repertoire for the post-classic period when the hieroglyphic books or the codices were produced. Now, in terms of encoding, this involved generating charts, mapping the signs into these hexadecimal grids or tables so that they could be encoded. So for instance, this sign here could be U plus 155A0 and so on, and this would be U plus 155A1 and so on. So in this way, we would able to generate preliminary code points for the purpose of encoding these signs. This was based on my collaboration with the Script Encoding Initiative led by Dr. Deborah Anderson and also with scholar Andrew Glass, and based on the combined expertise of Unicode experts as well in encoding Egyptian hieroglyphs or Meroitic hieroglyphs or Anatolian hieroglyphs. So there was previous expertise on how to encode ancient systems of the world, and we attempted to apply those proven methods to Mayan hieroglyphic encoding. One particular aspect that proved useful from Egyptian was the use of what is called as CJK, or Chinese, Japanese, Korean descriptors, and these kind of predetermined grids able to accommodate preordained configurations. Like, for instance, when you have two vertical signs side by side like these, you can use this particular configuration, which we called quadrats. And when you have three of them stacked on top of each other, we can use this other quadrat, which is encoded as 2FF3. So these are control, what we call descriptors that can be used in Unicode to arrange the signs that you are indicated under these particular grids or block internal configurations. So we started to apply these quadrats to Mayan, and they started to work pretty well to account for sign arrangements like this one here. Could be described pretty well by these types of quadrats. But in the earlier version, we had arrows indicating directions and so on, and this proved to be too complicated to be of practical use. So we started putting together a quadrat list, or a list of quadrats based on the different configurations that we were obtaining. Based on thousands of examples, we could arrive to a more abstract form. And by collaborating with Andrew Glass and Stephen White, we sought to devise ways to generate these quadrats automatically by simply tracing bounding boxes on top of the pages of the Mayan books like this. So this picture on the right shows you the list of quadrats, and each particular example here shows you the corresponding quadrat, or this diagram with a simplified configuration. But as we made progress along this line, we needed to simplify. So the quadrats that you see on the left in blue were the earlier versions, and then we came up with simplified versions. One of the differences that you see is that these ones have numbers inside each of the boxes, indicating the reading direction, whereas these ones are quite free. They work regardless of the reading order. It doesn't matter which of these signs reads first, which one reads second or third. We can still use the same basic configuration. And this allowed us, obviously, to reduce dramatically the number of quadrats. You can see here, before we had 164. At one time, we were closing to approach 200 quadrats. And with this, we were able to reduce the amount of possible configurations to 142. So this is an example of a virtual keyboard developed by Andrew Glass for Egyptian. And we were planning, we did a lot of work trying to apply the same methodology for Mayan. You can see how you can indicate the signs through different, by typing different codes on word processor like Microsoft Word, and you can indicate to enclose everything inside a royal cartouche and so on. And there were huge advancements made by Andrew Glass in this direction, and we were trying to profit from these new techniques to make possible to render quite complex configurations that we find in Mayan as well. So this required us obviously to generate a font, and we had different versions of the font, but you can see here that we were aiming at having quite abstract geometric forms, and we were using grids to try them on different proportions. But we also have the challenges that some signs are very complex. This is a representation of what we think might be an electric eel, so a sea creature. And there's only one example of this sign in the Paris Codex. So we had to render it pretty much as the actual example. And using this approach, we were able to fill out the gaps. This is what we call the phase one font, and create these Unicode charts with the code points for each of these Mayan characters. And thanks to tools that were provided to us by Adobe. Now, we started to apply the font that we were developing to the need of creating digital repositories of Mayan texts. So here is a section of the Dresden Codex, and you can see the actual signs. So this is glyph block 1, glyph block 2, 3, and 4. And here they are in a more sort of linear arrangement. But each of these glyph blocks unfolds into 2 or more signs. So this one unfolds into member A and B. This one unfolds into member A, B, and C, and so on. So first of all, we had to determine the quadrats that I was just explaining, or the configurations, the sign arrangements, and they were these types here. And secondly, we had to identify the signs using the codes that I devised. So the first sign here was A1, the second sign here was B12. This is the alphanumeric system of classification that I noted. And when we put all of this together, we were able to generate for the first time these more realistic renderings that approximate the actual pages of the Codex, because we were not only putting the signs, but also we were creating the correct configurations by using these quadrats. So we continue to apply this into Mayan. Here is an example with this particular glyph block. And using the same methodology, first we determine the quadrat type or the diagram configuration, then the correct sign IDs or sign identification. The first sign is F9. The second one is F12 within the glyphary that I was showing. The third one is G2. And the fourth one is A1. So we put all of this information into a virtual keyboard that Andrew Glass was developing. It was a prototype at this point. And we were able to make it work in a similar way to the Egyptian example that I was showing. We were able to force, so to say, these signs into the specific arrangements that, or these quadrat forms. And this was allowing us to stack signs on top of each other, to put 2 signs flanking at the left and the right extremes and so on. So, So what was all this for? Well, the idea was to use this font development and virtual keyboards to create digital repositories like the ones that already exist for Chinese classic literature, for instance. So this required us to map all the pages of the Mayan codices in ways that would allow to create these digital editions of texts. Here we see parallel text found in the Madrid and the Dresden Codex, codices, excuse me, sorry. And I'm gonna skip to how this effort required us to move backwards in time, because the codices come from the post-classic period around the 11th to 16th centuries AD, and but the largest amount of Mayan inscriptions exist in the classic period. So so we needed to expand our efforts into the classic period corpus of texts, like the ones painted on vessels that I was showing before, or the public stone monuments from Copan, from sites like Copan, Tikal, or Palenque. So in order to achieve this, I was already explaining our efforts to generate these initial font characters, or phase one font characters. And we had done several of them for the codices, for the post-classic, but we needed to do them for the classic period as well. And here is an inscription from Chichen Itza. And secondly, we needed to produce more quadrats in order to be able to account for sign arrangements and configurations that did not appear on the Mayan books, but only on these earlier inscriptions from the classic period. Here we see the character list for encoding the signs, and you can see the different categories that I was using to classify all these signs. Like I was talking about this earlier, like reptiles, birds and bats, mammals, fish, mollusks, shells, invertebrates, and other marine life, flora, including trees and plants and so on, food, drinks, and offerings, and so on. So we found that this sort of semantic categorization allowed us to accommodate most of the sign repertoire. But we needed a more advanced font, so we started to work towards phase two font characters, which were sort of cleaner representations. And I'm going to skip through a few slides to keep it short and have time for questions. But here we see how these three signs that we were designing, my colleague Céline Tamignon was designing these three signs on these grids. And this allows us to combine them using the sign arrangement that actually appears on the Maya books, like for instance. So we were replicating the arrangement, but with these new phase two characters, which were more accurate and were cleaner for the purpose of creating a Mayan font. Now, this Mayan font also has other advantages, like allowing to create us electronic representations of text. So we no longer rely on old drawings made by scholars, or here is an example of a digital picture which has not the quality that we need. So with the new font characters, we were able to render texts using these electronic characters and also replicating the sign arrangement on a cleaner way than it's possible with raster images, for instance, which show pixelation and so on. These are all vectorial, so they are scale independent and have other advantages for optical character recognition and so on. So here is an example of a digital edition from the Dresden Codex, following those principles. And with that, I'm just going to present a more elaborate example. So this is how it works. We have the actual example here on the left. And on the right, we have this electronic representation using the font characters that we are designing. And then we perform our analysis doing text markup and image markup, so that the each specific sign being highlighted here corresponds to the sign codes being used here, and so on. And each one of those sign codes has a specific transcription because they represent phonetic signs, like for instance, ta, I'm going to highlight here, ta, ha, tu, ta, chak, he, and so on. And ultimately, you want to arrive to a level of analysis where you can do transliterations of how we reconstruct ancient Maya speech. For instance, Walah, Yotot, Bolon, Bakwah, Bolon, Yat, Bolom, Ta, Ha, Tutal, Chakhi, and so on. And after the final, or one of the final outcome of the analysis is to arrive to a translation in English, or in Spanish, or in German. But you will know that the syntax in English is quite different than that on Maya. So our system is able to account for the different reading order that results from the different syntaxes used across languages. And with that, I should end. Hopefully we could still have time for questions, not before acknowledging the people and institutions cited on the screen. So I would like to thank and express my appreciation for So and for Kyoto University for the kind invitation. And hopefully we still have time for some questions, So.
Yes, we have time for questions. Thank you so much, Carlos, for a very rich and very informative lecture from the decipherment of Mayan hieroglyphs to the modern, very rich and massive project of encoding Mayan hieroglyphs. Yeah, thank you so much. So the audience, if you have a question, please unmute yourself and please go ahead. Any basic questions or any clarification question is welcomed.
Anybody would like to make any comments or any aspects that called your attention from the presentation? I could probably explain further any aspects.
Professor Miyagawa?
Yeah, please.
Oh, please.
Professor Miyagawa, can you hear me?
Yeah, I can hear you. Yeah.
Yeah, thank you very much. Carlos, thank you very much.
Thank you.
It's not a question, just my impression. I didn't know that kind of the area of the study. It's a kind of language description. And then I thought that's the area you are doing is so difficult to describe. We Japanese has a kind of still difficult, but I didn't saw the such kind of the collection of the tiny pictures, and then the making them the beginning stage of the research, and then I think you are kind of doing the continue endless kind of tough work, and then have you ever thought what you are doing is a kind of works, endless work ever before?
Andrew's work from Andrew Glass,
endless work, and the work is on and continue the endlessly. So
yes.
have you ever thought of that? Yeah, that's my impression of what you are doing. And then I saw sometimes the kind of web page the Professor Miyagawa created, and then the lots of kind of tiny character, yeah, rather than the character, they are the kind of the pictures. Yeah.
Yes.
And then it's pretty hard to interpret them itself, but the creating each tiny things is so tough work.
It was
just only the impression. Yeah, I really appreciate what you are doing. I think the young researcher, the foreign you will be a kind of very contributing to the area of that study. That's my impression.
Well, thank you very much, Professor Yamamoto, for your nice comments and your kind observations. Yes, it's very interesting observations about, well, first of all, I want to make sure I understood your question correctly. You are referring to Andrew's work with different script systems like Egyptian and other systems, and how we can apply now this to Mayan. And this was a fascinating aspect of the collaboration, because it's exactly as you mentioned, all these tiny signs and the sheer number of them. It's a lot of just for the post-classic period, we have 1,100 signs and variants. So we have well over 1,000. There's more than 1,000 signs that we needed to classify, and the number just increases when we go back in time and also try to classify all the signs from the classic period. Then we're closer to 2,000 signs, even more. So, and then they can arrange in because this was not a linear writing, but they arrange in almost, thousands of different combinations. So we realized that the Maya system was similar to Egyptian in this way, in the sense that both of them are very visually complex systems. They are visually very sophisticated, very complex, and we had to make a bet, and our bet or our theory was that the tools put together by Andrew with to deal with this complexity that you see in Egyptian would work, or would be able to work for Mayan as well. And so far they have been working pretty well. So far they have working pretty well, but of course this has been a long process. we started working together with Andrew since 2015, and we have still a lot of challenges to resolve, but we are getting closer to the aim of being able to create complete Mayan texts, like an entire book, using only these font characters, in the way that is now possible for Egyptian, for instance. Andrew has a nice example of the complete Rosetta Stone in Egyptian, completely created with these font characters that he designed. So we want to be able to do something similar with the Maya books, with the Dresden Codex and the Madrid Codex. But these are, of course, very pictorial signs, as you mentioned. And we had to, in order to be able to reach this point, we first had to classify them, to categorize them, and to essentially draw all these tiny characters to create the font. So it's been a long process, but we now have two different fonts, the phase 1 and the phase 2 fonts. Yeah, so I hope this can address some of the points that you were commenting, Professor Yamamoto.
Yeah. Yeah, thank you very much. I really appreciate what you're doing. And then the other same things, the other goes to the other Professor Morioka as well. And then the other very tough work is continuing. Thank you very much. I really appreciate what you're doing, as well as the Professor Morioka. Thank you very much, the other Professor Miyagawa. Back to you.
Thank you so much, Professor Yamamoto, for very kind remarks, and thank you so much. Does anybody have questions? If you cannot unmute yourself, it is okay to just write your question on the chat, or just raise your hand, or just unmute yourself.
I've got a question, please, Carlos. Thank you
Yes.
for such a fascinating lecture. That was so great. Thank you for that. Now, I was just wondering about the Mayan script and about its word order. Does it have a particular word order? I mean, in the Egyptian, we have verb and, noun and then object or something like that. How does it work in the Mayan script?
Oh, that's a very good question. Professor Li Zhou?
No, just Li Zhou.
Li Zhou, yes.
Yes.
I appreciate the question. That's a very, very relevant question. And to answer your question, let me see if I can go back to sharing my screen again. To show you the very latest example that I was presenting, because that might help to answer your question with greater detail. Right. Let me see. This is the example that I was showing, and if you look at the Maya row here, you would see that it advances in a very linear fashion.
Yes.
But if you look at the English language example, it takes all these leaps and sometimes it goes back. And this is because we had to adapt the Maya syntax to English language syntax. And so to answer your question, in English, we have what it's called what is called subject verb object syntax, or SVO, right? Yes. When we say, for instance, John drives to the store, right? Yes. Or we have the subject, which is John, the verb, which is drives, and then the object, right? The store. Now,
Yes.
in Maya, we have a reversed kind of syntax, which we call VOS. So it's the verb comes first, followed by the object, and then followed by the subject. So it's a VOS syntax. So if I were to translate the example I just did into Mayan, it would need to be drives to the store John, right?
Right.
But we cannot really, a correct translation therefore needs to take to account the syntax of each particular language according to the methods of traductology. So in Maya, we have this verb, object, subject. For instance, here is an expression, or for instance, we have first a typical example of a Maya inscription would be planted or set the stone into the ground, the king Pakal, right? Because we need the verb first.
Mm-hmm.
So it starts with inset or setting to the ground, and then the object, the stone or the monument, and then the subject, which is the king's name, right? But of course, in English, it sounds unnatural. It sounds kind of forced to do it in this way. So we translate it as King Pakal set the stone into the ground. For instance, this is with corrected syntax. And this is what we're doing in our system here. Essentially, the English part or the bottom row is being adjusted in syntax so that the translation can read more naturally.
Right. Thank you so much for that, Carlos. All the best with the project. Thank you.
Thank you so much, Lijo. I appreciate your kind wishes.
Thank you.
Thank you.
Okay. Thank you so much, Carlos, for a wonderful presentation. So sorry, it's up. The time is up. But if anybody has questions, please write it on the chat. And yeah, kindly Carlos will. Professor Tomohiko Morioka, do you have a short question or something? No? Okay. Okay, I see.
I have a small silly question about the input method. You demonstrate to input some human readable code F09 or E number, or instead of phonetic values. In the sense of Japanese or Chinese input method, we usually convert it from phonetic scripts to Chinese characters. Then you can make input method from phonetic values. Why don't you do that? And currently implementation, is there any reasons?
Yes, that's a very good question, Professor Tomohiko. If I may, I would try to answer briefly because I know we are almost up on time. But the reason that our input methods are not using phonetic values directly is because we explain here with the syllabary, right? Because, for instance, if we were to use ba in our input method, we would need to disambiguate. We would need to choose between all the different variants that exist for ba. Some of them are animal signs, some of them are more abstract, and some of them are multi-segment or segmented signs. And this gets more complicated with signs like U, for instance, if you look at U, you see a different, this can expand into over 20 different signs that were used for U. So one way to do it would be to write phonetically, but then you would need an option menu or some way to disambiguate between all the different options, which could be over 20 options or more when you consider distinct signs or graphemes, and you consider variants, which are is essentially the difference between a glyph and a character, right? So there can be 20 or more. And for this reason, at this stage, which is still a preliminary stage, we are using catalog codes, or what we call the glyphary codes. All these codes that you see here, like G2, A1, F9, F12, these are codes from the glyphary, which I designed. And the lowercase are descriptors. When you see VG and so on, like that, VG means vertical join, or you could also see HG, which means horizontal join. So this is a strategy that we are using to sort of deal with this complexity of having several different variants for a simple syllable like ka or like ba could be written in Mayan with 20 or more different signs. So using these codes and these descriptors is allow us to deal better with this complexity. So I hope this helps to answer your question.
Thank you.
Professor.
Very interesting.
Okay, so thank you so much, Carlos, for a wonderful talk. Thank you so much.
Thank you. So I appreciate the invitation.
Thank you so much for coming here. Thank you. So now we have the third lecture. Now we come to the ancient Egypt, and wait a minute. The presenter is Mayan Nederhof. He's a professor of computer science at the University of St. Andrews in Scotland, and he has been working for various projects, digital projects for Egyptology, especially St. Andrews corpus of ancient Egyptian, and also he is working for ancient Egyptian OCR, optical character recognition, and also ancient Egyptian Unicode, especially introducing the control characters for very complex layout of ancient Egyptian hieroglyphs. He's working in various fields in digital humanities for Egyptology. It's very happy to have your talk, Professor Nederhof. His talk is Unicode control characters for ancient Egyptian. So the floor is yours. Please go ahead, Professor Nederhof.
First, thank you very much for the kind invitation and for putting this interesting conference together. And now I will share my screen. This talk will be mainly about the control characters for ancient Egyptian. But rather than giving a dry laundry list of control characters, I want to say a few things here and there about the difficulties of navigating between the worlds of Unicode and ancient Egyptian. I will refer to concepts of Unicode that Egyptologists have found difficult to understand, and conversely, the misunderstandings in the world of Unicode about the nature of the ancient Egyptian writing system. Now, Unicode has been mentioned already a number of times this morning, or your time zone, whatever applies. Again, let me point out, however, that there are in Unicode the visible characters that you can see on the screen, and there are control characters which control how visible characters are rendered. So a classical example is the tab. You can't see a tab on the screen, but you will see that a character following a tab is printed somewhere else on the screen. In principle, Unicode is not involved with things like paleography, so very exact descriptions of what things look like. To give an overview, it is only relatively recently that there are hieroglyphs in Unicode. This has already been mentioned by Professor Palan earlier on. So there are 1071 hieroglyphs in Unicode since 2009. With these alone, you can only put one sign after another, and this is unacceptable to Egyptologists because this is not how the ancient Egyptian script looks like. And then since 2019, there are 9 control characters that allow us to put these signs next to one another, above one another, more or less as you might find it in an actual inscription. And much of this talk will be about the new control characters. There will be at least a doubling of the number of such control characters so that we can do more things than before. And this is a joint work with a number of people. I would again mention Andrew Glass, who has had the difficult task of persuading the Unicode committees, and he also has been working on a prototype of the font, not just for the existing 9 control characters, but also for the new ones that we hope to propose. And I also have to refer to the extension of the sign list beyond the existing 1071 characters, because the 2 issues are related. Now, ancient Egyptian is a little bit different from everything else, and that is something that people in the Unicode community don't like to hear, because they think that if we already have encoded 150 different scripts, then surely the next script will be just number 151. But there are a few things that are peculiar about ancient Egyptian. First, the sign list is very open-ended. So we have heard the interesting talk by Professor Morioka earlier this morning, that of course also in ancient Egyptian, sorry, in Chinese, there are, just as in ancient Egyptian, always more signs, more characters if you look hard enough. But I would still argue that the situation for ancient Egyptian is even more serious than that. It's also very hard, again, perhaps even more difficult than in Chinese, to distinguish between an independent character and a graphical variant of an existing character. And then we have the spatial grouping together, the relative positioning of signs which causes complications. And then there is almost no text in ancient Egyptian that starts at the beginning and ends at the end. Most of the texts are fragments of text. And the representation of damage of a text or of a text starting halfway, one character, you could perhaps try to represent on a higher level protocol. So we have CSS, for example, for applications on the web, where we can indicate damage by shading text, a part of a text, or printing letters in a different color. Such higher level protocols are very difficult, however, to combine with an encoding of groups of signs. That is because the interface between the CSS and the sequence of characters is difficult to make. It is very difficult to indicate on a higher level protocol that certain characters within a grouping of signs are damaged. The elephant in the room is always the Manual de Codage as implemented in JSash. So JSash is a widely used tool that implements Manual de Codage, and it is used for typesetting hieroglyphic text. And it was designed for the purpose of producing printed publications. So the idea is that you have your encoding, you run it through your encoding, you get an image, and this image is then included in a printed publication. And after this, you can throw away the encoding. So the meaning of an encoding is basically what it looks like once it has been printed. And JSash allows all kinds of fine-tuning, and the tool itself can be customized to include more pre-composed groups and all of these things. Then Unicode is a bit different. It has different objectives. Whereas for JSash, the interchange of an encoding with a colleague is not really at the center. In Unicode, this is what it is all about cross-platform encoding, composing and encoding on one machine by one person, and then sending this encoding to someone else working on a different platform and having a reasonable expectation that it will look the same. There's also a concern in Unicode that if you have a certain appearance, then there should be only one way of encoding it. And that is for the purpose of search. Because if you're searching for occurrences of a certain writing, then you would be very disappointed that if your search query doesn't match a certain appearance, even if it is the same thing as your search query. And also Unicode is not really very much concerned with the exact details of what things look like. Now, JSash is so important for Egyptologists today that it's sometimes very hard for them to understand that Unicode has very different concerns. And I've seen a cultural shift from a total disinterest in Unicode on the part of Egyptologists who were very cynical about Unicode, like the writing system is much too complicated to express in Unicode. And anyway, those people in the Unicode committees don't understand our needs. I think the pendulum has now swung in the other direction, where at least a number of Egyptologists have really embraced Unicode with the new control characters, but now expect Unicode to solve all of their problems and to allow them to publish their texts now in Unicode rather than in very specialized tools such as JSash. But the kinds of sophistication that you find in JSash simply cannot be implemented one-to-one into Unicode. And that has been a source of lots of misunderstandings in the recent past. As I mentioned, I also want to refer briefly to the repertoire of signs, because it interacts with concerns about the control characters. And one of the things that has not been understood in, at least until recently, in the world of Unicode is that one cannot approach the task of building a sign list as if one were making a stamp collection. From my simplistic point of view, stamp collecting is by taking a heap of stamps and taking one stamp at a time from this heap and comparing it to stamps already in your albums. If a stamp is the same as a stamp in your album, then you know it is a duplicate and you can trade it in with someone else. If a stamp is different from any stamps in your collection, then you can add it to your collection and proceed in this way. But this comparison quickly breaks down. So for one thing, the stamps in your collection in this case are normalized glyphs that you can take from existing printed books. But these normalized glyphs had a certain purpose in those books. And if you take the shapes from different books, you don't really get a sign list, you get an unassorted collection of shapes. And so the confusion between shapes and signs consistently confuses people. And also you need to decide the granularity of encoding. And the word granularity of encoding, I think, has already been mentioned earlier this morning by Professor Moriak. So to give a few examples of the difficulties that arise if you don't distinguish shape from sign. In the official Unicode code charts in 2020, you could find this sign for A48. And if you compare this to the original code chart when this sign was introduced in Unicode in 2009, then you see there's a difference. There are a few differences. One difference is that the sign has been given a beard. Now, the rationale was, well, we have all these little men, and some of them have beards and some of them don't have beards. And that is make everything a little bit more uniform, which sounds quite plausible if you come from the perspective of, for example, alphabetic scripts, where the letter A and the letter B, well, they are different shapes, but they have, you would normally give them similarly shaped curves and the same thickness of lines. Until you realize that Gardner, in fact, intended this specifically to be a beardless man. So a beardless man has now been given a beard, which is a contradiction in terms. Similar for B7, we now have a beard, or at least until quite recently this year, we had a beard in this sign. Again, added for reasons of uniformity. Also, the hairstyle has been completely changed. But now, in fact, this was supposed to be a queen. So you see the difficulties that arise. And if you build a extended sign list, and there was mention of a extended sign list of about 6,000 or 7,000 new signs to be added. If you compile this list by comparing shapes without realizing the signs behind them, then this is going to be a disaster. Further, at some point, you need to make a conscious decision about the granularity of encoding. What kinds of details do you want to encode in your code points in Unicode? So this is an example of 4 shapes from the tot sign list. This is the standard guinea fowl, the neg bird, which has a lappet and a feather sticking out from the head. But you occasionally find that the lappet is missing, or the feathers are missing, or both of them are missing. Now you could say, well, let's just include them all in Unicode. We have plenty of free code points, and so it can be useful to have all 4 to your disposal. But on the other hand, if you are not careful, then this will completely explode. Consider, for example, the Sheshep fence, 042. In the pyramid text alone, there are about 24 different variants of this sign. Do you really want to have code points for all of these? And where will this ever end? So what is the correct way then to extend a sign list in Unicode? Well, you need to stop treating shapes as equivalent to signs. And the only way to do this is to define a code point. You define a code point in terms of its identity. And that is a combination of defining the graphical features, the iconic features, what does a sign represent, and the functional features, that is, how is a sign to be used. And why do we need functional features? Well, to take a very simple example, we have lots of circles in the sign list. We have a circle for the pupil of an eye. We have a circle for a grain of sand, for an abstract geometric shape and so on. And they are to be used for different purposes. And even though they look similar, they are different characters, different graphemes, different signs, just as the capital O and the digit 0 are different things, even though they both look roughly like circles. And then you also need to make sure that the signs that you introduce in Unicode actually exist. And so you need to go back to the sources and verify the shapes. And this work is now happily currently being done. It started roughly at the beginning of this year. And for me, these people are heroes because this is a very tedious, meticulous work that requires a lot of effort. Jorke has put a lot of effort just in understanding the existing 1071 signs, verifying their existence in corpora, and finding out how they are used so that we now have a linking, a mapping from the code points to a description in the tot sign list. The tot sign list has as goal to look at different signs with different witnesses, different variants, and so on, how they all relate. And this work is guided by statistical data. So the efforts to introduce new code points in Unicode will give a priority to the signs that are most frequent, so that the hapax signs that occur only once in the corpus may still be encoded, but at some later stage. Now let me go to the control characters. And to motivate these, let me start by giving an example of two lines from a stela from the 12th dynasty, together with a transcription that is now possible with the control characters in Unicode. Now, if you look at a drawing of this stela, then you see that sometimes two signs are next to one another. And two signs next to one another can be below another sign. So then we have already vertical arrangement and horizontal arrangement. And this can in fact be nested. So if we go to this corner in the second line, then we see that there are two strokes next to one another, which together are below another stroke. And this is next to another subgroup. And all of this together is underneath another sign. And there is no bound in principle to how deeply this could be nested. Further, we see sometimes that a sign is in the free corner of another sign. And with this bird here, we in fact see two signs that are inserted in free corners. Now, many things we won't be able to exactly render in Unicode. So, for example, the beak of the bird is opportunistically put in, between two other signs. And so this is one of the features of the ancient Egyptian writing system, this attention to the aesthetics of avoiding ugly, empty white space. So very often signs are squeezed together a little bit to minimize that amount of ugly white space. But there are limits in Unicode, and so we don't try to encode this kind of kerning of signs in one another. So armed with this understanding of how inscriptions look like, we need to now think of the control characters to introduce to be able to express some of this relative positioning, this formatting of signs within groups of signs. And of course, we need to do this in a way that we can actually implement in fonts. And for this, we want to have a simple system where we have very powerful control characters, because it wouldn't make any sense to introduce a new code point or some new control every time we have to study a new text. We want to have a small set and then have a reasonable confidence that even if we haven't seen a text before, then we can still, with the existing repertoire and the existing control characters, we should be able to transcribe this text. So we have already seen a vertical arrangement, one sign underneath another that is indicated by the colon, and we have seen the horizontal arrangement, two signs next to one another. And we assume that the star for horizontal arrangement has a higher precedence, operating binding value, so to speak, than the colon. So we have here a group of 3 signs, and the last 2 signs are next to one another, and then together they are underneath the first sign. Because of this operator precedence, sometimes we need to use brackets to group things together in subgroups. So here we have 2 signs, one underneath another, and then this together is next to one sign, and then this these 3 characters together are underneath yet another sign. Now, this is relatively straightforward, and any meaningful encoding system for ancient Egyptian has always had these 2 primitives of horizontal arrangement and vertical arrangement. Now, the big question is, what else do we need? And for this, we borrowed some inspiration from plot text. Plot text was an early system for typesetting hieroglyphic text. It was a competitor of the Manual de Codage. It was in all respects far superior than the Manual de Codage, but for some political or other reasons, it simply didn't make it. It doesn't. So these days, it is almost forgotten. But it had exactly what we needed for Unicode, which is 4 primitives. And so I'm using here the Unicode notation. This plot text had a different notation. 4 primitives that put a sign or a group of signs in the free corner of another. So we have here the sun in the free corner next to a duck. Here, similarly, this goes in the upper left corner. We can insert more than one sign in more than one corner, as you see here, the 2 signs in 2 different corners. A group of signs can together be put in one corner, and also this corner insertion can be combined with the horizontal and the vertical joiners. Then there's also the possibility to put one sign over another in the ancient Egyptian writing system. That is called the overlay. So you see some simple examples of one sign on top of another. It's also possible to put a vertical or horizontal group on top of another. Now, this is something we really had to fight for. And in the first instance, the Unicode committees were not happy with this at all. They argued that this should be treated as a monogram, with the idea being that this is simply a new character which could be given a new atomic code point. However, we kept insisting for a very good reason, and in the end, common sense prevailed. And this reason is that this is productive and compositional. So to give an example here, we have these 3 signs with an overlay. If you analyze this composition, then you see that this is purely compositional. It is in fact a phonetic and almost alphabetic spelling of 3 signs. Each of them stands for 1 consonant. And in spellings that use this overlay, you can also find alternative spellings where these signs are separate. So the picture is emerging as the overlay as being just one other way of combining hieroglyphs next to vertical and horizontal joiners. And it would not be feasible to enumerate all such overlays as you could if they were truly monograms. So happily, we have them in Unicode at present. Okay, so these were the existing control characters. Now let me turn to the ones that we hope to introduce in the next few years, and it will probably not be in 2022, possibly 2023 or so. The first new control character is a bit like the insertions we have all seen before, the corner insertions, but in this case we insert something inside of another sign. So again, there has been the idea in the Unicode community that we could simply turn this into separate code points. And in fact, there are atomic code points at present that are middle insertions. But if you look closely at the corpus, you see that the number of such atomic code points would be very, very big. So we want to avoid this. This also makes search easier if you can look for the decomposed sequence of characters rather than to know which code point represents such a combination of signs. So here are some simple examples of middle insertions. Here is an example at the bottom of two signs that are together inserted inside of another sign. Then we also have insertion at the top of another base sign. So the top insertion, again, we see an example here of sometimes of more than one sign being inserted at the top of another sign, and similarly at the bottom of a base sign, you can have an insertion of more than one sign. Now, cartouches and other enclosures, this was a bit tricky. So an enclosure, by this we mean something enclosing hieroglyphic text. And this looks a bit like the middle insertion that I talked about 2 slides before. The difference here is that the amount of text that is enclosed, as in this example of a cartouche, the amount of this text is in principle unbounded. It can be very long text, and the cartouche stretches out proportionally to how long the enclosed text is. There were already in Unicode code points for the so-called caps of these enclosures. And one potential encoding would have been to write the beginning cap, then the text, and then the end cap. But there were a few problems with this. One is that sometimes we actually don't want to have these connecting lines between the caps. In particular, when we are transcribing hieratic, where cartouches don't enclose the text. They are separate beginning and end caps. Another problem was to be able to encode damaged cartouches, because remember again that the majority of the ancient Egyptian texts we have are damaged. They start somewhere halfway a text. And the solution was to introduce 2 extending controls that represent the connecting lines themselves, but not the caps. So if we have a full form cartouche enclosing text, then we can use these 2 blue, well, in my slide here, they are blue. We can use these 2 extending characters to represent the connecting lines between the caps. And then we can choose appropriate caps at the beginning, at the end. But one of the caps can be missing, as in the case of this damaged cartouche, and then you can replace it by some kind of shading character to indicate that the text has been damaged on that side of the cartouche. Both caps can be missing, and if you want to transcribe hieratic, then you don't use these extending characters. And in that case, you get the isolated caps. Another control character that we want to propose is mirroring. And there are many situations when the ancient scribes would mirror a sign. So normally, if you have animals and people, they look towards the beginning of the where you have to start reading. So they look towards you when you're reading a line from left to right, or in the case of a column, from the side of the column from which you're reading. But sometimes these signs are mirrored. You often see this for reasons of symmetry in, for example, in cartouches. So you have here two figures, and one figure doesn't want to turn its back to the other figure, so they look toward each other. So that means that one sign is opposite to the normal reading order. But there are many more signs that are almost randomly mirrored. So you have many signs that don't have a clear directionality, that don't have a clear back or front. And so we felt we absolutely needed to have a mirroring control character. And so this is an example of the use. We have the S29, which is mirrored here to give a variant. For rotation, it was very important to be able to have some kind of mechanism to obtain rotation. So we did some systematic analysis of a number of texts from different periods, and we found that very often if we couldn't encode something with the existing 9 control characters, it was because of rotation. Now there are some code points for rotated characters already, but we found many more characters rotated that do not exist as atomic rotated characters. The point about rotation is that any sign in principle can be rotated, and especially signs which are narrow and high or low and wide. That is for aesthetical purposes. This is a good example. With Unicode presently, we can at best encode this as this. Now this looks ugly because there's all this ugly white space. The ancient artists found that if they would rotate this character by 90 degrees, it all fits much nicer. Here are some more examples. So rotation with 90 degrees very often happens. So the tall, narrow signs very often are rotated by 90 degrees counterclockwise, and the low white signs are often rotated with 90 degrees clockwise. But you also find rotations by 180 degrees. For example, in this example from the statue of Ahmose. We had hoped to introduce control characters for this, but we got the advice from the Unicode committees to use variation selectors. So variation selectors are fixed symbols, they're existing symbols, characters in Unicode that you can put after another sign to create a variation of that sign. And we can use these, we can interpret for ancient Egyptian, we can interpret the existing variation selectors in a particular way to obtain a rotation by 90 degrees, 180 degrees, or 270 degrees, and possibly for, say, 45 degrees for a few signs where this is relevant. Because the majority, again, of text in ancient Egyptian is damaged, is partial, we also felt we needed to have a mechanism of indicating damage. And we are proposing a control character to be put after a sign to indicate that it is damaged, and it's usually done by shading or by hatching, as it is also called. And we can even indicate that a part of a sign is damaged, a quarter of a sign individually. So if you want to indicate that the top half of the sitting man is damaged, then we use a shading for the top left quarter and the top right corner. In addition, if an entire block group is lost, then we can introduce an atomic shading character, and these two can combine with one another. The last one that I want to discuss, which we felt initially to be quite controversial and problematic, but it seems that we got sort of the green light from the Unicode committees to go ahead with this. So this is the blank. And there are some examples where signs are missing in a hieroglyphic transcription. That is not because they are damaged or because they have been erased, but simply because they were omitted. So one example among many is if an artist was copying a text, but the original was damaged, then in their copy they left that text blank, as in this example where there's a blank space here in the original inscription. Now, the implementation. This is problematic. And as I already mentioned, Andrew Glass has put enormous effort in implementing these control characters in Opentype. Now, why Opentype? Well, this is heavily pushed by Microsoft. And these days, if you want to propose something new in Unicode, you have to provide at least proof of concept that it could be implemented in Opentype. Then again, Opentype is the worst possible choice for ancient Egyptian. It is a horribly designed kind of font technology and has severe limitations. It doesn't allow dynamic scaling. And so why do you need dynamic scaling? Well, if you have two signs, one above another, and those signs together don't fit within the height of a line, then you have to squeeze them together. You have to scale them down to make them fit within the height of the line. But because Opentype doesn't allow this dynamic scaling, the only thing you can do is to include several copies of the same hieroglyph in your font in different scaling sizes. So, for example, we could have 7 different copies of the same sign. Also, there's no arithmetic, so the computation that you would like to do to determine how much a sign has to be scaled down would ideally involve an addition and a division. So you add all the heights of the signs together, and then you divide by the height of the line, and that gives you the scaling factors. But that is not possible in Opentype in principle, although you can try to simulate it in a very tedious manner. Which is why Andrew's work has been miraculous. What he has accomplished is quite impressive. Another limitation of Opentype is that there can be at most 2 to the power 16, which is roughly 65,000 different characters, and that is including all the scaled variants. Moreover, ancient Egyptian is written both left to right and right to left, and rows and columns. This means that you need to have 2 copies of each character as well in each scaling. So if we make a simple calculation and we find that if we were to extend the number of hieroglyphs to about 5,000 in total, we would get more glyphs than we can fit in an Opentype font. And that is a really serious problem. So it also has some implications for extending the sign list. We should not go overboard, because soon we will get something that is so big that we can't implement it anymore. And note that this doesn't even consider rotation, because for every rotated sign, we would need 2 times 7 more glyphs in our font. Now this prototype is being developed. I'm not sure yet when it will be released publicly. A lot of work still has to be done. There is, however, some positive thing to be said about this, namely that you can, for certain limited applications, solve the problem in an easier manner. So, for example, this GitHub implementation, which I built a few years ago, what it does, it analyzes a corpus and then creates a font that is able to represent all the groups occurring within this this corpus. And this is much easier to do in this way, because then everything that is complicated and difficult to do, you can do outside of the Opentype technology. This scaling and this positioning can be done in an arbitrary programming language. In this case, it was Python. And then your font, your Opentype font, has to do something very simple, simply to look up for a sequence of characters, including control characters, how they should together be rendered by a pre-composed group. Another possibility is to use JavaScript, another general purpose programming language, and that works well as long as your application is for the web, because JavaScript runs on the web. It won't run in your word processing tool. So I can demonstrate a few things if there's time left.
Yeah, you can. Yeah, please go ahead, Professor. The next speaker, Professor Nishioka, said her presentation is relatively short, so you can take more extra 10 or 20 minutes until 15 past. I don't know which 15 past 19 in Japan time, but you have 25 minutes. Thank you.
Okay, thank you. Let me try to share my screen. If I can find my Firefox. For some reason that is missing. Let me try again. Okay, here it is. Okay, so this may possibly be the first application of the Unicode control characters on the web. This is a 3D model together with a transcription. And so what you see here is actual Opentype technology being rendered on the fly inside of a web page. And I can even prove that this is Unicode. If I go to the sources, then you see here the Unicode control characters. And this will also allow me to do, for example, search. I can search in this page for a combination of hieroglyphs together with a control character. And you see this is being highlighted here. And then we can also show the application of these control characters on the web. So this is a editor for hieroglyphic text. So, for example, I can write the sitting man, sitting woman, and underneath I might have a couple of strokes. Let me give an example of the corner insertion. So here you have the chick with the T in the corner, and here you see the encoding that we get. This is the Unicode code sequence consisting of the characters, the glyphs, and the control characters. Okay, that is all I have.
Okay, thank you so much, Makian. It's so fascinating talk. Yeah, I was following your work, but it was the first time for me to see the middle insertion and also Opentype app on GitHub. It's so wonderful. Thank you so much. Yeah, so since Professor Nishioka, the next speaker, said her presentation is relatively short, we have 20 minutes for questions and answers. Does anybody have questions? If so, please unmute yourself or write it on the chat or just raise a hand. If none, I have a question. Yeah, I'm very curious about the middle insertion. I got I think that you show the whose sign and F sign inside whose sign, and I'm very curious about how you manage with the font and so on, because of the size of whose sign changed a lot, right? It was much widened, right? How do you manage with that?
So the first thing we do if there's a middle insertion in a sign which is relatively small is to choose a variant of that sign that is bigger, big enough to hold the material that you want to insert. So I believe that Andrew's implementation has only one such larger shape. You could think of more sophisticated implementations. For some combinations of signs, it may be unavoidable to precompile the form. So if, for example, for the pair sign that I showed, you would have to know what you want to insert before, and then choose a particular form of the pair sign, knowing that it exists for a certain number of particular inserted signs. So it will be a combination of something that works on the fly for any combination of the base sign and the inserted sign, and a number of pre-composed combinations of signs. Now, lots of the inspiration was also gleaned from the work that I did on the res. Res was meant as an alternative to the manual de codage, and there the insertion is a bit more strict. It doesn't use any kind of pre-composed computation. What it does is it first scales down the inserted group to just one single pixel, and then slowly makes this inserted group bigger and bigger and bigger until it almost hits the base sign, and then it stops. And then it might also be shifted a bit up and down to make it fit. That is a quite expensive computation, and that is not possible, obviously, in Opentype. Now, what we do for Opentype, at least what I do in my implementation, I think Andrew has something similar. That is that we analyze a font automatically using FontForge. We print the characters, and then we try to analyze by looking simply at what pixels are black and which are white. We try to analyze how much space is available. So if you have a corner insertion for a certain bird, there might be more space available over its head and its back than for other signs. And so given a font, we do this analysis automatically. And then this is once and for all. And then when you are actually typesetting a text, then you know how much text is available, and so how much to scale up or scale down the inserted signs.
Yeah, thank you so much. It's very wonderful. Does anybody have questions? I also would like to ask about the possibility of OCR with your system. How do you also work on? I know you are working on OCR for ancient Egyptian hieroglyphs, but have you already implemented these control characters for it and so on? And how far is it? When can we use your system?
For OCR, you mean?
Yeah, OCR with Unicode.
Okay, the work that I did on OCR is quite a number of years back. The goal was to take a handwritten transcription. So I've looked at the handwriting of Sete in the Urkunden. And so to take this handwritten transcription, just a scan of the book, and then to translate this to an encoding. And so this is for the res encoding, which is somehow has similarities to Unicode, but it's a little bit different. It also has the insertions, the corner insertions, has the side insertions, so top and bottom, as well as left and right. So one of the arguments I made while doing this is that the kinds of primitives, these insertions, are quite convenient for OCR because so once you've recognized the characters, that is of course the first step, just taking the say the connected components, all the black pixels that connect together, and knowing which character, which sign they represent. The next step of finding the appropriate control characters is relatively easy. So by just looking at the X and Y coordinates of one sign and another sign, you can easily determine whether one is inserted in another, whether you should see one sign as the base sign in which another sign has been inserted. So my argument while doing this research and working on this OCR implementation, my argument was that these primitives are a natural way of analyzing the relative positioning between different signs. And this to contrast it with other things that have been tried in the Manual de Codage traditions, such as the ampersand. So the ampersand is a quick and dirty hack to simply say, I have a number of signs, I put an ampersand between them, and that means some kind of grouping together of these signs, but I don't know exactly which it is. And then another alternative might have been the absolute positioning of actually saying this sign should be at this XY coordinate relative to this sign. Which is, I believe, overly precise and not really suitable for things like exchange of encodings between different peoples working on different platforms.
I see. Thank you. Yeah, I know that ampersand is very, very vague strategy to use. Yeah, I often use JSH, and with ampersand, it can automatically be fixed, but sometimes it is not as I wish. So I just use the editor, graphical editor, to modify it. But yeah, with your strategy, it is very, very nice that we can make a layout of glyphs very precisely. It is very, very it is very, very important for the study of hieroglyphs and also Egyptian philology. So I think your system has its very great potential. It will be the future method to input and also record hieroglyphic writings. And thank you so much. And so here we have some Egyptologists in the participants, do you have any questions?
Yes, I do. Thank you so much, Mark, for that fascinating lecture. Thank you. Now, I do have one question. I do use JSesh, and it's a fantastic tool. But what the problem that I have is I can't, I have to copy it across, not copy it across, I have to make an image of the hieroglyphs and then paste it into my Word document. Now, is there a way we can actually type directly into the Word document? Can it somehow interact with Word to make it easier for us?
Yes. So what Andrew has been working on is input methods that work on the level of the operating system. That means that if you work with Word or if you work with just a plain text file, it doesn't matter. You type certain keys and they are then translated to appropriate control characters and hieroglyphs. And then if you also have configured Word to use a particular font, then you will actually see groups of hieroglyphs inside of your Word document. So this should in the future be possible. So I still believe that there should be probably most Egyptologists in the future will probably make use of a combination of the Unicode control characters. Mm-hmm. If they have, for example, a running text, so if they have a text of English and then they want to refer in this text to English to some name, which is in hieroglyphs with nice groupings of signs with control characters. And then there will also be, when you publish a new text, you will also need JSesh again for the primitives to very exactly put the signs next to one another and to fine-tune the scaling factors and so on, and have special annotations for which parts of the text are damaged. So I believe there will always be a combination of Unicode for running text and JSesh or similar tools for the exact representation of the original inscription.
Oh, that'd be wonderful. Thank you so much for that. Thank you. All the best.
Thank you.
Okay, questions and comments? If not, Mark, do you have some remarks, or do you have more further demonstrations of your apps?
I haven't prepared any further demonstrations.
Okay.
I think I've about filled a whole hour. So thank you very much for your patience.
Okay, so thank you so much. Thank you so much, Mark. Thank you so much for joining us, and it was wonderful to have your lecture here. Thank you so much.
Thank you.
Thank you. Okay, so yeah, we have a very intensive day of lectures today, but thank you so much, everyone. Yeah, so this is the end of the first session. On character encoding. We had lectures on character encoding on Chinese, Mayan, and also ancient Egyptian hieroglyphs. It's super wonderful to see all the progresses and also the ways to encode these very complex characters. Yeah, it's very nice to, it's a bit a pity that we don't have so much time to discuss, but yeah, I'm thinking to have a kind of a platform to discuss these kind of things somewhere. I'm not so sure on the Slack or somewhere, but mailing list, but I'm thinking about that. But thank you so much. Three presenters for your wonderful talks. And without a pause, sorry, but yeah, sorry. We don't have so much choices because today is the only day we can gather together on Saturday, so sorry. But we go on to the session, the next session on digital archiving and curation. The first speaker is Jifumi Nishioka, Professor Nishioka from Kyoto University Library. She has been working on open science and linked to open data, and also the IIIF, and she's also developing the digital archive of rare materials in at Kyoto University, and she's also a specialist of using IIIF technology, IIIF framework, international image interoperability framework for the rare materials of Kyoto University. And today her talk is the development collaborations and evaluation of the Kyoto University Rare Materials Digital Archive. Yeah, so Professor Nishioka, please go ahead.
So can you see my screen?
Yes, I can see your screen very well.
Oh, great. So thank you very much. Kind introduction. I am Chifumi Nishioka, working at Kyoto University Library since 2017. And in the library, I am involved in the development of the Kyoto University Rare Materials Digital Archive. So today I will make a presentation about development, collaborations, and evaluation of the digital archive. So this is the outline of this presentation. So I will present the development, collaborations, and evaluation of our digital archive. So before going to main contents, I would like to introduce some phrases and their intended meanings that are used in this presentation. First, digital archive refers to websites that provide access to collections of digital material. So it has same meaning with digital collection. And second, rare material refers to resource, including historically important manuscripts, maps, and drawings. Then I would like to start from the development of the digital archive. So we, Kyoto University Library, have digitized rare materials over 20 years. The digital images of different collections have been published on the web in different ways. In this style, there are several challenges. From the perspective of users, digital archives use a variety of applications such as viewers, and it results in a different user experience at every digital archive. So users are necessary to run new features and controls at each digital archive. And from the perspective of developers, they have to implement different applications with similar functionalities many times. So there are a lot of duplicated implementations. So to resolve these challenges, IIIF has been launched in around 2012. IIIF is an acronym of International Image Interoperability Framework. According to an official presentation, IIIF is defined as a community that develops shared APIs, implements them in software, for example, image servers and image viewers, and exposes interoperable content. So this is a brief introduction to IIIF. In recent, IIIF has been considered as a standard to deliver images of cultural resources. IIIF defines a set of APIs that provide a standardized way of delivering images and structural metadata over the web. Before the development of IIIF, digital collections are developed at each institution, and data of image servers can be used only by specific applications. So the data is closed into the silo. In contrast, IIIF makes interoperability by defining APIs. So data on image servers can be used by different applications over different institutions. Using IIIF, we launched the Kyoto University Rare Materials Digital Archive in December 2017. The digital archive has been supported by Kyoto University Open Access Promotion Project, whose purpose is to enhance resources in humanities by digitizing images of rare materials. And at the moment, Digital Archive publishes over 1.6 million images of 20,000 titles. And this is a screenshot of the top page of the Digital Archive. The Digital Archive supports Japanese and English, and users can switch languages by top right toggle. Below, users can see news, pickups, and collections. In pickup, we provide several categories in which important and popular rare materials are classified. This is a bibliography page. At the bottom, you see the metadata of the bibliography. To improve discoverability of our rare materials, we added titles in Roman characters to metadata. At the top, the universal viewer is embedded, so users can quickly look through images on this page. We choose universal viewer as default viewer due to its simplicity. At the middle, we provide the links to IIIF Manifest, Universal Viewer, and Mirador. So this is a Universal Viewer. It supports a right-to-left direction, which is suitable for most Japanese manuscripts. And this is Mirador. It also supports the right-to-left direction. According to our analysis, Mirador is used as many times as a universal viewer. So we think that it is very nice to have both implementations. And regarding the system configuration, our digital archive system is composed of content management system, which is Drupal, and image server, which is IIP image server. Drupal manages contents other than images, including website design, metadata, and viewer. We have a manifest.json generator, which is a customized Drupal module. So when our staff registers a content using Drupal, the manifest file is automatically generated. In addition, Drupal provides the search functionality. In the image server, over 1.6 million images are stored in the format of TIFF. And our users can also reach to the rare materials not only from digital archive, but also from our OPAC. As shown in the red square, the bibliography page on OPAC provides a link to the corresponding bibliography page on the digital archive. Curation, which is our OPAC, and the digital archive store the identical metadata of rare materials. Curation enables users to find rare materials using advanced search, which is not given by the digital archive. So through the development of IIIF compatible digital archive, we unlock our rare materials. After the launch of the digital archive, we have started to work for collaborations. So this slide summarizes the collaborations for the digital archive. Collaborations can be classified into two categories. The first one is collaboration with institutions that hold rare materials. The objective is to improve discoverability and accessibility of rare materials. The second one is collaboration with research communities. In these collaborations, we ask researchers to enrich information of rare materials, such as metadata and transcriptions, so that some values will be added to rare materials. In this presentation, we introduced a project, Digital Fujikawa, History of Medicine in Japan, as a collaboration with institutions that hold rare materials, and a satellite Daizokyo database as a collaboration with research community. So I would like to start from Digital Fujikawa. So first, let me introduce to the Fujikawa collection and motivation behind the project. The Fujikawa collection is a collection which is comprised of about 9,000 books formerly held by Dr. Yu Fujikawa. These books had been collected by him for writing his masterpiece, History of Medicine in Japan. The books in the collection have been separately stored in different institutions, so that researchers using these books have requested to see the books in one place. And using IIIF, we try to bring the books into one place on the digital space. So to this end, we launched a project which is called Digital Fujikawa History of Medicine in Japan. This is a collaborative project between Kyoto University Library Network and Keio University Media Center. The project has two objectives. First, we contribute to the development of research in the history of medicine in Japan by providing the comprehensive view of the Fujikawa collection to researchers. Second, we provide an example showcase of digital unification utilizing IIIF to community. In September 2018, we have launched the beta version of the Digital Fujikawa. At the moment, the beta version contains almost 6,000 books from 3 different institutions. In February 2019, books from the University of Tokyo have been added to the Digital Fujikawa. The digitization of books have been financially supported by these grants, including a grant from the ministry and a project by the National Institute of Japanese Literature. And regarding the implementation of Digital Fujikawa, we made a lightweight implementation. Since we can access to the server only via FTP, we do not use any software. Instead, we implement functionalities using JavaScript. This is the main screen of Digital Fujikawa. As you see, we show title, author, publication year, and holding institution of books at each row of HTML table. We add function and sort function to HTML table using data tables, which is a jQuery plugin. And users can make keyword search over titles, author, publication year, and holding institution. We provide sort function at each column. We attach hyperlinks to each bibliography page at titles. At each row, we provide a link to IIIF Manifest, Universal Viewer, Mirador, and IIIF Curation Viewer. And this is an example of a comparison of books from Keio University and Kyoto University Library, enabling search and browse on the same portal. The distance between books on the digital space is shortened, and we can make such comparisons very easily. And also, a topic is a little bit unrelated to the development of collaborations. I would like to mention about the influence from digitization of our library holdings. This table shows the number of appointments to physically access to each collection with respect to financial year. The Fujikawa collection had been ranked in the top 5 over years. In the financial year of 2018, the collection had dropped out of the top 5. We think that a possible reason is that the collection can be accessed on the web due to digitization. In addition, the total number of appointments has decreased over years. Therefore, digitization and publication of rare materials can decrease the workload of librarians, as well as traveling time and expenses of researchers. So then I would like to introduce a collaboration with a SAT Daizokyo database as a collaboration with the research community. In this collaboration, we have added reciprocal links between the digital archive and the SAT Daizokyo database. The SAT Daizokyo database is a full-text search service for the texts of 85 volumes of the Taisho Shinshu Daizokyo provided by the SAT Daizokyo Text Database Committee. The Taisho Shinshu Daizokyo is a definitive edition of the Chinese Buddhist canon, including Japanese commentaries used by scholars. The reciprocal links connect a bibliography page on the Kyoto University Rare Materials Digital Archive and the corresponding page on the SAT Daizokyo database, so that users can refer to full text on the SAT Daizokyo database. The reciprocal links are generated based on metadata that had been provided by researchers on IIIF Manifest for Buddhist Studies. The IIIF Manifest for Buddhist Studies is a platform that collects over 8,000 manifests regarding Buddhist study materials from different institutions around the world. A IIIF Manifest is a resource defined by the IIIF Presentation API and corresponds to one rare material. In the field of Buddhist studies, there has been a practice to assign catalog numbers to each piece of a rare material. so that different versions can be compared. The platform enables researchers to register IIIF manifests of rare materials related to Buddhist studies. In addition, the platform encourages researchers to browse images of the rare materials and add catalog numbers, volume numbers, and line numbers to images. This added metadata is delivered to SAT Daizokyo database and is used to generate reciprocal links between the SAT Daizokyo database and bibliography pages in the digital archive. So in summary, this collaboration shows a pathway in which users provide added value, such as catalog numbers and volume numbers to rare materials. Then the added value is given back to institutions that made the rare materials available. So we can see that the distribution of the rare materials through IIIF brings benefits to both users and institutions that hold material. Therefore, we would like to continue to work for collaborations in the future. Finally, I would like to present our attempts for the evaluation of the digital archive. Evaluation of a digital archive is important to find better ways to digitize, publish, and share rare materials. In addition, it is important for accountability for stakeholders and to get grants and fundings continuously. So far, several evaluation frameworks and guidelines have been developed, including European Impact Playbook and guidelines for the evaluation of digital scholarship in historians. The common principle of the frameworks and guidelines is that evaluation should be conducted in accordance with the objective of a digital archive. Looking back to the development of the digital archive, the objective of our digital archive is to support researchers. So we will attempt to measure to what extent rare materials available on the Kyoto University Rare Materials Digital Archive have been reflected in research. For the purpose, we actually encourage our users to share scholarly outcomes that use the rare materials. Specifically, we ask users to donate copies of academic publications that use rare materials to the libraries. However, we find that most users do not. We receive less than 10 scholarly outcomes per year, but we know much more scholarly outcomes use the rare materials. Therefore, we think that it requires an automatic procedure that captures scholarly articles using the rare materials. So we came up with two strategies to capture scholarly articles using the rare materials. The first one is usage statistics. In this strategy, we first identify the most accessed materials to understand trends of research by analyzing server logs. Then we search scholarly records such as journal articles and department bulletins that mention the most accessed rare materials. The second strategy is retrieval of scholarly articles using API. In this strategy, we attempt to get scholarly articles that mention a rare material using API of scholarly article database. So we show the result with respect to each strategy. For usage statistics, we actually count the number of pages and the number of hits as metrics, because these metrics have been widely used as measuring the usage of websites. The number of pages counts accesses to HTML, PHP, and ASP files. On the other hand, the number of hits considers accesses to all files, including CSS, image, and JavaScript files that are requested as a result of loading page. So this figure shows the number of pages and the number of hits between October 2017 and July 2021. So in the figure, we see several spikes. We identify the causes of these spikes by detailed server log analysis. The first spike has been caused by a news article by Kyoto Shimbun that mentions the Fujikawa collection. And this spike in 2019 has been caused by National Center Test for University Admissions. This is a nationwide examination for university admissions in Japan. And the tale of Tamamizu has been taken up as a subject of classical Japanese literature, so that many people get access to the tale of Tamamizu, which is available on our digital archive. And there was another spike on May 2019. This spike has been caused by a news article by the Kyoto Shimbun, which mentions illustrations of the emperor's accession. And the most recent spike has been caused by Amabie, a character that became very popular during the pandemic of COVID-19. So just for your interest, I would like to introduce some rare materials that had been accessed many times. The first one is an illustration of the accession of the emperors. We hold rare materials included in Nakai collection that depicts plans regarding the accessions of Emperor Sakuramachi and Empress Kosakuramachi in 18th centuries. In Japan, the emperor's accession took place on May 1st, 2019. Therefore, the rare materials attract a lot of people at that time. The illustration represents Takamikura, which is imperial throne, and attending courtiers. We see that all of them so colorfully and finely depicted. And the recent huge spike of usage statistic has been caused by Amabie. Amabie is a legendary Japanese mermaid or merman who allegedly emerges from the sea. And Amabie prophesies either an abundant harvest or an epidemic, and instructed people to make copies of its likeness to defend against illness. So that during the pandemic of the COVID-19, Amabie became very popular in Japan. Actually, many artists published their illustrations of Amabie on social networks, such as Twitter. And Amabie also appeared on official poster for stopping the spread of COVID-19 by Ministry of Health, Labor, and Welfare. So then let me get my own track. In the usage ticks, we observed several spikes. We found out that they are caused by media such as the newspaper or tweets. Therefore, we think that usage statistics reflect societal impacts of the rare materials to some degree. However, it is very difficult to understand trends of research and to what extent the rare materials are used in scholarly outputs. Then I would like to show our attempt based on the second strategy. In this strategy, we retrieve scholarly articles that mention the rare materials using Shiny Articles API. Specifically, Shiny Articles open search for full text. Shiny Articles is a database that indices scholarly articles published in Japan. We set queries for API as title is as a combination of title of a material, space, and Kyoto University Library in Japanese. This shows an example of a query. And as a result, we received a lot of false positives. In other words, we got scholarly articles that are identified as mentioning a rare material, but actually do not. Therefore, we conclude that it is difficult to identify scholarly articles that use a rare material automatically only using Shiny Articles API. And during the analysis of user statistics, we found out another challenge. The user statistics revealed that 40% of hits come from foreign countries, such as China and the United States. It indicates the rare materials are possibly mentioned and used in scholarly articles in foreign countries. So we would like to investigate a automatic method for to capture scholarly articles that use our materials in English and other languages in the future. So in summary, we conclude that the two strategies could not capture scholarly outputs that use our rare material well. And we would like to argue that understanding scholarly usage of a rare material is important not only for our evaluation of the digital archive, but also for supporting research. Because we think that information regarding related works of rare materials and how they are used will support researchers. It allows researchers to see what research has been conducted so far on rare materials. So our digital archive has a page that presents exhibitions and research that use rare materials. The page provides the list of exhibitions and the list of research projects that are highly related with the rare materials. And to correct use cases such as the research outputs, we think that we need a framework that instructs how to cite a rare material and extract citations. To do so, we first would like to further promote open access of different scholarly resources in the field of humanities. At the moment, many scholarly articles in the humanities remain in print and are not available online. In this case, it is difficult to detect citations. And we also think that scholarly resources other than articles should be made available online. Researchers in the humanities produce scholarly outputs in various forms, including monographs, and scholarly editions, and so on. Those resources should be considered as well. We think that citations among different types of scholarly resources should be made available in line with an international standard, such as the one defined by the Initiative for Open Citations for Broad Distribution. In the future, we would like to provide not only resources such as rare materials, but also connections between scholarly resources represented by citations. So this is a summary of this presentation. So in this presentation, we introduced Kyoto University Rare Materials Digital Archive. The development of the digital archive is supported by Kyoto University Open Access Promotion Project, whose objective is to enhance resources for research in humanities by digitizing our rare materials and making them open access. For broad and interoperable distribution of rare materials, the digital archive is IIIF compatible. After the deployment of the digital archive, we work for collaborations with other cultural institutions and research communities. In this presentation, we introduced Digital Fujikawa as well as reciprocal links with the SAT Daizokyo database. For the evaluation of the digital archive, we tried to capture to what extent rare materials used in scholarly outputs. Through the attempts of the evaluation, we found out that usage statistics reflect societal impacts of rare materials, and it is very difficult to capture scholarly outputs that use rare materials in an automatic procedure. In the future, we would like to continuously work for the challenge as well as facilitate further distribution of scholarly resources, including rare materials, through IIIF and other standards. So in the final slide, I would like to express my our gratitude to institutions and research communities that work with us, and I also thank to our colleagues, my colleagues at Kyoto University Open Access Project, a promotion project team, and Kyoto University Library Network. So thank you very much for joining my presentation.
Thank you very much, Professor Nishioka. It's very wonderful to see the, digital Kyoto University Rare Material Digital Archive is now accessed by so many people. I have a kind of question about the statistics of visitors, especially last year, the National Diet Library, NDL, and other organizations launched Japan Search. But they use, I know they also have IIIF images from Kyoto University Rare Material Digital Archive. Do you also count these accesses in your statistics or not? And what engine, search engine, I think Google or other search engines do the visitors mostly use?
Thank you for the question. And can you listen to me?
Yes, I can listen to you.
I would like to on my camera.
Yeah, I can see you.
Okay. So thank you very much for the question. And first, I think that Kyoto University Rare Materials Digital Archive at the moment does not participate in Japan Search. So but we participate in National Diet Library digital collection, which is another engine, and I saw the usage statistics include accesses through these kind of platforms, such as National Diet Library digital collection, because I think it also uses IIIF.
Yeah.
And the second question is about search engine, right?
Yes. Type of search engine.
I think, yeah, I think as you expected, Google is the most used search engine, but Yahoo Japan is also used very well. But I don't know why. Yeah.
Because
yeah.
Yeah, because in Japan, many people are still seeing Yahoo News.
Yes.
And Yahoo, they use Yahoo Search maybe.
But I can say that a lot of accesses are from from Twitter because of some tweet including the link to our digital archive retweeted many times, such as 10,000 or 100,000 or a million, and they directly jump to our digital archive from Twitter.
So they are not only researchers, but most of them are academics.
Yeah, I guess so.
It's very, very interesting. And this biggest spike is for Amabie.
This, I think this, can you see my?
Yes, I can see you in person.
This large spike is in January 2019. So this spike is caused by the national center test for university admissions. So center scan. Yeah. At that time, the tale of Tamamizu has been accessed very much, because our digital archive also not only provides images of the resource, but also translations into modern Japanese language, so that I think many students or people access to our digital archive page to check correct Japanese modern translation of the literature.
It is very nice to hear that possibly many high school students access this digital archive. I think this is very, very nice also for education as well as for research. Yeah.
Exactly.
Thank you. Does anyone have questions or just basic? Yeah, it is also okay with very basic questions or just remarks or comments. If you have questions or remarks, please unmute yourself. Bati? Okay, so I have another question then. I'm very interested in the which image is the most accessed. Is it so? Yeah, you see, you can yeah. I know the tale of Tamamizu and also Amabiye were accessed the most, but yeah, without this kind of newspaper or like buzzing in the tweet, what kind of material is accessed the most?
I think that so I would like to stop my sharing and so can you see?
Yeah.
Let's switch into English. So this is the top page of our digital archive, and at the pickup, we show some rare materials and very rare materials that are very popular one and important one, and especially this is Konjac Monogatari Shu is specified as national treasure. So it's very important. So that this material has been accessed many times, and also especially from foreign countries such as the United States, many people access to these colored illustrations. So including the tale of Tamamizu, but other rare material also includes fine pictures, and also we have English translation of the story, so that many people access to this kind of material. I think they are not scholars, but yeah, they interested in Japanese culture.
Yeah, indeed these images are very beautiful.
Yeah.
So many people yeah, many people like them, I think.
Yes.
These images were like displayed on other sites, other websites introduced by other websites and so on?
I'm not sure, but actually, we allow distribute images if they clarify the attribution of images according to our conditions of use, so that I think some people use the images in other websites, or yeah. But I'm not sure, but we are very interested in how other people use our rare materials. And this is also very popular one. I think many Japanese know this picture because I think Japanese history textbooks typically have this picture. in the,
It's old spelling of German, right? Or-
yeah, right.
Yeah. Okay. Oh yeah, there's a question from Guanwei Liu. Could you unmute yourself? Sorry, could you unmute yourself, Guanwei?
Sorry. Can you hear me now?
Yeah.
Thank you, Miss Nishioka. And you said there are a lot of access from American, just
American,
a lot
yes,
of access from American. And do you get any chance? Do you know that's why there's a lot of user outside of Japan? Cause when I was in the Hokkaido University, I have a server which was running the HTTP viewer Japanese dictionary database, and I have almost half of the user that from America, but I don't even have an English interface. I just don't know why there's a lot of users that from America have to access this database. Do you have any clues?
Unfortunately, I have no idea. So yeah, I think many different IP, we get accesses from many, not specific IP, but many different IP addresses. So that I think that there are a lot of users in the United States. So yeah, we are also interested in that, the motivation behind the accesses from the United States. So I'm sorry for my answer.
Okay, thank you very much.
Yeah.
Any other questions or just a brief remark?
May I say a few comments?
Yeah.
First of all, thank you very much for your substantial presentation. I'm a researcher of minority language spoken in China, and actually, thanks to your presentation, I've found manuscripts stored in Kyoto University. So I just wanted to express my gratitude to you. Thank you.
Thank you very much. I'm very happy to hear that.
Okay, thank you so much. Thank you so much, everyone. And thank you so much, Professor Nishioka, for a very wonderful talk. All right, so does anyone have any questions? Okay, thank you so much. So yeah, thank you. So we have, the last but not least, it is otori in Japanese. Otori is kind of climax and most important role of kabuki theater, I think. It is the last person but who come to the stage, but she or he is the most important actually in kabuki tradition in Japan. Our last speaker is Francis Canetta. Dr. Francis Canetta is a famous Egyptologist, museum curator, and also a digital humanist. She has been working on religion and literature in classical Egyptian, also in Demotic, and also Greco-Roman and late antique periods, mainly in Egypt. But her scope is very wide, and she's also working as a museum curator and also a digital humanist, and she's famous for her work in digital Rosetta Stone with Monica Verdi at the University of Leipzig. And she's currently working at Saxon Academy of Sciences and Humanities in Leipzig. So her presentation is current trends in digital editions and curatorial practice, examples from Leipzig, London, and Stellenbosch. So Franziska, floor is yours.
Thank you so much. So it's so great to be here, and thank you so much for the invitation. And without further ado, I'm going to share my screen. So there we go. Just sharing parts of it in order to see my notes. Just a second, it's going to be in the right shape right now. So I hope you can see the presentation in the correct way. Thank you so much. There we go. Yeah, so Miyagawa knows already a couple of things about that because he was also present at some conferences that we did back in Germany. So a big thanks go out to you, so my friend, and also to Professor Chigusa Kita, who organized this wonderful venue. Thanks again for the invitation. I really appreciate it. It would have been, of course, great to be with you because I've been once in Japan. This is now more than 10 years ago, actually, a couple of days before the horrible tsunami, and visiting my friend, another Egyptologist, Ikuyo Kato, who's also with us here today. So hello, Ikuya, also from Waseda University. And I also have to thank Professor Nishioka for speaking about IIIF and giving this wonderful introduction right before me, because I couldn't have said it in any way as the way you could. And also thank you so much for sharing the user statistic. That was also a great insight. And I think my colleagues and I were going to rewatch then the video, because this was a great insight also for us, because we are just starting with IIIF for a couple of projects. So what I'm going to talk about with you today is a couple of examples. The digital Rosetta Stone, so mentioned this already. Then something So was asking me to talk to you about. This is the Papyrus Ebers, a famous scroll on Egyptian medicine housed in Leipzig, which was newly put on the internet by the IIIF technology. And the third example I'm going to talk to you about is what I call digitizing the ancient world in South Africa. I am also a visiting professor at Stellenbosch University in South Africa, and from time to time, I'm going to teach them about digital humanities, digital curation, and things that involve that. And we went to some museums to have a look at the artifacts there and make them visible through 3D models and digital exhibitions. So today is going to be, and this is why it fits in the session about digital exhibitions, combination of research and making our primary sources, in this case from Egypt and the ancient world, available for the public, for the researchers to work with the material, to share it, and so on and so on. So this is once again the agenda for today. Just to give you a name of this South African collection, this is from Isiko Museum. This is a huge group of museums in the city of Cape Town, right down at the Cape in South Africa. And one short word of introduction to the place where I'm working now since 1.5 years. So mentioned that I'm working at the Saxon Academy of Sciences and Humanities in Leipzig. You can see the German logo right at the bottom part, left part of this page. This is a newly found center where my two colleagues, Dirk Goltan and Peter Mühleder, and I are working in the field of digital humanities and all kinds of historical disciplines. That means from ancient Egypt to modern research. Also, we are working together with colleagues who are researching now the COVID-19 pandemic in social media from a historical and social history point of view. And we are supporting them not just in research, but also in development of tools in research data management and other parts. It's a very vibrant community, and it's very interesting because you get to work with so many people and with so many different topics in your research. So not just Egyptology, but a lot more. And this is challenging in one way, but also very rewarding. So it's amazing how many people I have got to know in this last 1.5 years, and so many things that I've been learning. Yeah, let's start with the Digital Rosetta Stone project. That's the largest part of my talk for today. This is now going on since a while. We had the idea for providing a digital edition of the Rosetta Stone in 2014, 2015. This is when we were starting, and that is so mentioned this already as well, Monica Berti. Now, like me, Privatdozentin, Dr. Monica Berti, we both got our habilitations this year, and she is a classicist currently standing in for the chair of ancient history at Leipzig University, and coming from the field of Greek and Latin literature. And when we saw that there was a grant application open for doing a project in the intersection of research and teaching, we applied for it, we got it, and we hired Miriam Amin and Josephine Hensel, 2 colleagues from Egyptology and Digital Humanities. And the main phase of the project, when these people also were actively working and paid, was 2017, 2019, because we got some extra grants, but we are still working on it. So it's over, it's not funded anymore, but it's sort of funded by our positions, because there's also more people that we're working with. And we're, for instance, actively collaborating with the British Museum and the Egyptian Museum at our hometown in Leipzig, because both are planning big exhibitions next year, because the decipherment of the hieroglyphs will be 200 years next year. So it's going to be a big year for Egyptology, and also with colleagues from Berlin and elsewhere. So the starting point was actually that Monica Berti was creating a database called the Digital Fragmenta Historicorum Graecorum. So that's ancient Greek texts provided in modern state-of-the-art digital exhibitions, and you can check out all the websites that are mentioned here, and I'm going to show some also at the end of each section. So, and then this collection is the Greek version of the Rosetta Stone. And then she said, why only the Greek version, since it's 3 versions on this text? So this is how we got into contact and had the idea of doing a project together, because as some of you, or I guess probably many of you know it, and the Rosetta Stone was also cited in a lecture today as well. It's consistent of 3 inscriptions, the top part of it being written in hieroglyphs in the Middle Egyptian language, which is a very old-fashioned language at the time when the stone was erected. So some kind of, shift to the past. Then the contemporary language and script, the Demotic, and the ancient Greek part at the bottom. This reconstruction here of the stela with the text is highly problematic. It's actually the only thing that we have right now. This is cited everywhere, also all over the internet. There's going to be a new idea of how this stone might have looked like when it was still complete. And this is going to come out in a new book by Stefan Pfeiffer and Friedhelm Hoffmann, and I just heard this yesterday, they've just been delivered their author copies, and this is a new translation in German, though, of the Rosetta Stone, and they are going to provide with a new idea how this might have looked like. But it's all speculation. We don't know what the depiction at the top of the stela was. And stela, that's the point. The Rosetta Stone was a stela erected at the temple, and there must have been many copies of it, but almost none of them have been recovered so far. And it's basically a decree of the pharaoh having a couple of rules, a couple of obligations, which he came to together with the priests. So we also call them trilingual decrees or priestly decrees. So the pharaoh and his officials met with the most important priests of Egypt to come to these decisions that are in. I don't want to go too much into detail of the contents here, because that's also something you can check out at our website and everything that we did with it. Just a few facts and figures. 196 BCE was the date when the stone was erected, or to which the contents are dating. And this is in the time of King Ptolemy V, who was only 12 to 13 years old at the time. So you can imagine that his officials and members of his family, the Ptolemaic ruler dynasty in Egypt, did most of the politics in that time. And it's called Rosetta Stone because it was found in the city of Rosetta, which is a town in the Nile Delta in Lower Egypt. The material is pretty hard. If we then go into digitization, it's granodiorite. It's a very dark stone, almost black. Yeah, and if it would have been complete, it would have been more than 1.50 meters in height. You can see at the right side part of my slide another degree of that kind called the Canopus degrees. These are students from a class of mine when we were working with the so-called Canopus decree, and you can see this is a facsimile of the original height of this text. So you can see it's definitely high. There's still students in chairs hidden behind the part of the facsimile, just to give you an idea. The history of the Rosetta Stone is also hardly debated, and the British Museum is getting problematic messages on social media all the time. They're posting something because, of course, much of that is coming from the time of colonialism, and a lot of it was acquired in what we wouldn't consider a nice way or even a legal way, even after the legislation in earlier time. And it's also been mentioned before that first the French have recovered the stone from the city of Rosetta, but then they lost against the British. So the stone, which was destined for the Louvre, never made it to Paris, but was later then recovered for the British Museum since 1802. And there's a couple of very famous copies of the stone from that early time. Yeah, it was important, of course, because it helped Jean-François Champollion to decipher the hieroglyphs. We know now from archive study of German Egyptologist Wolfgang Schenkel that the Rosetta Stone was actually not the most important monument for decipherment. It was actually the so-called Banks obelisk, which is standing in front of a very nice aristocratic house in Dorset, Kingston Lacy. That's the location where the obelisk is standing, but also Champollion himself made the Rosetta Stone, as you can say, the poster boy for the decipherment of Egyptian. And when I teach Demotic for beginners, we of course also have a look at his writings in the famous Lettres à Monsieur Dacier. Greek epigraphy was pretty quick at deciphering the Greek part, and it was also very early on. The lacuna of the stone, the missing part, were very early and easy filled with reconstructions because the knowledge about ancient Greek was never lost. For Egyptian, it's a bit more problematic, and we are still not able. So because of the missing part in the hieroglyphic section on top of it, we are not able to, fill the gaps as we could do it for the Greek part. Yeah, and something Mark Nederhoff also talked about today is also, of course, an issue in general for Egyptology is when we want to produce digital editions, of course, we would like to do this with the help of Unicode. For now, not all the hieroglyphs that we would need are available. This is why for the project in 2017, we decided to only have transliterations of the Egyptian version, not the hieroglyphs or the demotic signs so far. So if that's available and if we have all the signs and we have to check this regularly, we would also like to have the hieroglyphic versions, of course, online. Yeah. And we also needed at that point when we got started good photographs. So more about that in a bit. First of all, I'd like to go through you to one technology that we did called textual alignment. We started out with a technology called Alpheus. But first of all, what is textual alignment? This is a method for the comparison of text and languages, and also very well suited for learning foreign languages. So many of your languages app you might use on your phone or your tablet are based on on alignment. So first of all, with using Alpheos on the Perseus environment, which is a big website for the ancient world, for having all these tools for in digital humanities for analyzing mostly ancient languages, was a tool where you can actually add. We did this here with the German and the English version of the Rosetta Stone, and then you click on different words in one language and then the other, and then you match these with each other. And so you can easily learn or study the languages. But there's been only 2 boxes here. This is why we needed something else. And fortunately, at the beginning of our project, this became available. The UCARIT translation alignment editor. This is actually also something that was produced in Leipzig at the Department of Digital Humanities by our colleague Tariq Youssef, and it's now widely used all over the world, including a certain So Miyagawa, who is regularly contributing to adding more texts into this portal. And I'm going to show you this in a bit, but first go through the slides. Here you have 3 fields where you can insert 3 text boxes. And this is, of course, where we inserted the 3 versions of the Rosetta Stone and also translations. If you like to know more about how this works, how you can use it on your own, because you can use it for any language or languages that exist out there, I strongly recommend our study class Syllabary, and I will also give you the links in a bit to this class, because we have sessions and you can rewatch them on YouTube, which deal with how to use this tool. Let's have a look here at the alignment with a couple of our graphics that we put into it. So here is, for instance, this was typed in the program JSesh, not yet Unicode, a hieroglyphic version. And then we have the demotic version. There's just a image of the demotic writing on the stone, and then the Greek version, all one under another, and a German translation. And then, of course, you can click on individual words and align them with each other. I just want to single out one easy thing. This is not going to be a crash course into ancient Egyptian, no fears. There is Netcherut in Egyptian, that means gods and goddesses. So we have here a plural of the gods, the female and the male ones, expressed in the hieroglyphic version, that is the Middle Egyptian, by these 2 plural forms, but no article. In the Demotic, we have, this is the red rectangular brackets, na netcheru. That is an article, na in plural, netcheru, just gods, male form in plural. And in Greek, we have just hoi theoi, an article and the word for gods in plural. And those are the matches together with the translations here in German, gods and goddesses, the gods, the gods. So this is how we did this. You have to make some decisions when you want to align things, because as you can imagine, things in Egyptian are expressed rather differently to things in Greek. Sometimes they use relative sentences, sometimes they use participle constructions, but it expresses the same thing. Sometimes there's idiomatic language and so on. And this is really a nice tool to get to the core of these differences. And it's a nice tool to use in class, a nice tool to communicate findings to interested laymen and women, but also for research, of course, to get to the core of issues. And at some point, we would like also to present an article with a couple of findings that we have. What we found out is that there is some things that are expressed differently, some things that might be errors, or some things that might be culturally different, the Greek world versus the Egyptian world, because according to state-of-the-art research, those decrees, like the Rosetta Stone, are modeled after a Greek fashion. So there are Greek honorary degrees, which also existed in 5th century Athens. And this is the model from which these particular kind of decrees are created upon. Just for your information, decrees as a text type existed in Egypt already from very early on. We have already in the 3rd millennium BCE examples for decrees, but not with this special kind of formulaic language. Yeah, and there's more examples. Sometimes we are lacking the hieroglyphic part because it's not preserved. There's just educated guesses what might have stood there, and yeah, sometimes there's many words, as you can see here in the blue bracket, that we put together with something corresponding to the Greek, such as epithets and so on. So this is one thing we did with the Rosetta Stone project, the alignment. Another thing we did is tree banking, and this is still work in progress. So far, the tree banking has been done for ancient Greek. But first of all, what is tree banking? So this is a way of visualizing sentence structure and the morphology, the syntax, and the semantics of words. And once again, there is something coming from Leipzig. This is not something we invented or anything we had a say on it. It's called the Leipzig glossing rules. That just because we do have a Max Planck Center for Evolutionary Anthropology here, and they came up with these rules, how to gloss a text, how to say what kind of sentence that is, how to annotate the morphology, what is a predicate, plural, and so on. And those rules have been standardized, and this was done at the Max Planck, at one of the Max Planck centers here. And if you do this correctly, and the computer has in the background the grammar of, in this case, ancient Greek, then you create a tree. And this is why it's called tree banking, a tree with a root, and it has a couple of branches coming out of it where all the parts of speech, the parts of text are connected to each other. And this is also a nice way of visualizing grammar. Also use it for teaching and also for homework. If students, for instance, get a sentence they have to annotate in the tree banking portal, and this one's called aretusa. If they manage to create a tree, then they know they were right. If the tree is not visualized on the website, then there must have been a mistake somewhere. So that's an interesting way of learning the grammar, which is of course always the hardest part in most of ancient languages. Okay, there's different kind of views you can have for this tree banking, and this is all available online. You can all have a look at this and zoom in, and especially at a Rosetta Stone, zooming in is the point. It's only consisting in the Greek version of 29 sentences. This is not a lot, and those sentences have more than 50 words. Never do this when you write articles or when you communicate with people, write emails. This is just horrible, because we know, especially if you work in press and public relations, you know that the average adult is stopping after 12 words per sentence to pay attention. And with children, it's different. Academic audiences, of course, they stop after 19 words, but still, don't write words like in the Rosetta and sentences like in the Rosetta Stone. In order to work with it, we needed to scan the stone again. We were very happy that colleagues from the University of Florida in Gainesville joined us, Angelos Barnputis and Eleni Bosia, both professors, one in classics, one in computer science, and they developed a very interesting tool called the Digital Epigraphy and Archaeology Project, where they have been digitizing also not just artifacts, but also squeezes in different institutions all over the world. And they have found a new technology to scan, especially those inscriptions, which have not a lot of depth. But if you want to create true 3D images, this is a very great way of doing so. Here's our setup at the British Museum. After a while, we got permission to go there, scan the stone in the morning. Had a dark blanket over the showcase, which was fortunately opened for this purpose. And you can still see this kind of light called ice light. This is what we use to create light from different sides, from the left, the right, the top, and the bottom. And this technology is called shape from shading. And then at the end, from these 4 images, one image is created, which is a true 3D image. And you have one of these raw photographs here on the left-hand side part of the slide, and on the right side is the combined image where you can see the inscription much, much better. And this is especially the most problematic part that we highlighted here. This is the top left part of the Rosetta Stone. This is where people have been experimenting with putting chalk on the stone, trying to clean it in a way to make the hieroglyphs more visible. And this resulted in a couple of fails. That's why the stone is so faded here now. So the color was really suffering by these experiments, but we were still able to get some good photographs. And we could also help a lot of colleagues working with the Rosetta Stone right now. For instance, these people I mentioned that just wrote a book about Rosetta Stone, our photographs help them with their translation work. Yeah, so that's definitely sorry for the glitch here in the screen. It's definitely an improvement, and you can see a couple of publications if you like to know more. And you can also approach me if you would like to have these links to these publications from our colleagues. Yeah, and then you can play and reconstruct depth traces and so on, create a depth map. Yeah, and they did this with a couple of other things. When we then had a very nice photograph of the Rosetta Stone in 3D, we worked on the visualization. That's what Miriam Amin was basically doing. She put coordinates on the photograph, and then we were able to highlight the different parts, some passages of sentences in the 3 versions on a website. I'm going to show you the result in a bit, just for those interested in that. This is at least structured information put on by the HTML on the website, and then creating the different units that belong to this. And we also use that, I mentioned this already, in teaching, and we had good results because very often students just do what they're supposed to do to get their grades. But in this case, I can say that they went the extra mile. They did more than they were supposed to do. They even used this for different languages in their other study courses. So we were very happy with them. It was small groups though. You need to have people who are really interested. And one lessons learned aspect is that you need to assign more time for troubleshooting with computers, with the software, because that takes quite a while at the beginning and you have to explain things sometimes a couple of times, but the reward then could be really nice, and it's a new way of learning. And especially during the pandemic, we know that a lot of people, for instance, came to the Synoikos classes. As for perspectives, we like to go on here, do the tree banking for the Egyptian. This is still work in progress, and hopefully at the hieroglyphs, and at one point also the demotic in Unicode. And of course there is more text that we could work with. We put up some other degrees like the Rosetta Stone, but there's definitely a perspective for more. And then we also have created a digital exhibition about that. Showed you this also in a bit by the program Omeka. That's been adapted for what's called the Deutsche Digitale Bibliothek. That's a large corpus in Germany where national objects nationally are collected, and they have developed with the exhibition tool Omeka an extra version, and I was just trying that out for work and created a German and English version of a little exhibit where you can basically see what I told you once more. So that's the part of the Rosetta Stone. We're moving on to Papyrus Eris in a bit, but firstly I am stopping screen share and do it again for showing you the websites. This is just because I always need a different resolution here. No, it's not doing what I want to do. Just a second. So there we go, and switch to my browser. So first of all, here is Ugarit. It's ugarit.eyeliner.com. And you can see there's even also Japanese text aligned here in this whole network. Most of it is English, ancient Greek and Latin, but there's also Egyptian and Coptic. And there's one user called Digital Rosetta Stone. Surprise, surprise, that's us. And there you have the synoptic version where you can go through different parts of it. We actually put up a couple of versions. I think I just got the wrong one. That's the one that I wanted to show you. But yeah, just play around a little bit with this. This is our website. On the website, we do have the visualization or visual alignment. That's what I'm going to show you. And there you have this nice photograph. And if you hover with your mouse over it, you will see the different versions aligned. For instance, now if I go down here in the demotic part, you can see at the top part the alignment in the hieroglyphic version and so on. And of course, you can fit this according to your screen size. And if you stay on it, you can see the transliteration of the Egyptian. And if you click on it, it takes you to Ugarit once more to see the translation of this part and the alignment with the other languages. This is the digital exhibition. And I just briefly scroll through it because it's also something I wanted to play with, a technology I like to explore. There's also audio guides and things and lots of images from the Rosetta Stone, its reception, how it looks like in the British Museum, fancy kind of merchandise that's been done. With it. So there's a lot you can buy involved with the Rosetta Stone things that we did. That's me in the Egyptian Museum when I was giving an interview when the project was had its first conclusion and lots of information to it. So there's still a lot to see and lots of links. And this is the study course Synoikis. Just copy this briefly for the chat. And there you can see it goes on since a couple of years already, since 2016. And if you click on each of the years, for instance, the syllabus that was just concluded, there's another one actually going on. You can see that there is lots of classes, if you go on, that have been conducted to all kinds of topics, to digital humanities in the ancient world, and project that presented itself. For instance, I was hosting sessions about the Book of the Dead in 3D, or the new Turin Papyrus platform. We've been talking about lots of issues, and you can join live on YouTube, or you can rewatch it later. Okay. So going to Papyrus Ebers, our second topic for today. This is one of the hugest scrolls that we have from ancient Egypt. And just to give you an idea how huge it actually is, I'm zooming out. It's 18.63 meters long if you count all the text, and that has been, of course, cut into class frames, 29 class frames. A couple of them are missing, because during the Second World War, Leipzig University put out its treasures in a nearby castle, and some have been even found in a doghouse. So those are, for instance, some that are missing. They've been found in a doghouse. Yeah, there's still some missing, but they've never been recovered. The missing ones have been supplemented here by a facsimile that fortunately existed. And the university library, where it is stored right now, actually just newly created a facsimile, and will open a showroom next week. Next week it's going to be open. This will be interesting event. So I couldn't present you images of it today because it will be just opened in a bit. It's a very beautiful handwriting. It's written in Middle Egyptian and in Middle Hieratic bookhand. If you are keen on paleography, it's dated paleographically to what we say the New Kingdom. So that is 1500 BCE roughly to the 15th, 16th, 17th, or 18th dynasty for the Egyptologists here, to give you an idea. Very beautiful hand, and also the production of the papyrus is amazing quality, also compared with texts which are much younger in Demotic or in ancient Greek coming from Egypt. And this whole website, that's why we included in this talk here, and that's why So was asking me, was redesigned in order to have it all done with IIIF. So everything that Professor Humi was showing you with the IIIF manifesto and everything, that's also in the backlash of here. And what you can also do is translation on and off. And you can imagine, to have a roll of this length of 18 meters, you need to scale this down in a way in order to be able to do such fancy things, to have the English translation here. There's also a German and an Arabic one, but if you hover with your mouse over this website, as I was doing right now, you can get the translations. Actually, these translations need to be updated at some point, because we have very new versions. My colleague Lutz Popko from the TLA, the Thesaurus Linguae Egyptiae, this is a website you can see here, also has a newly translated, a new translation of it. And this is one of the main sources of translations and transliterations for Egyptian texts. And this is a team from Berlin, Leipzig, and elsewhere who add the spells, in this case, the recipes and the spells of this medical papyrus. And if you go in the text, it's a very old-fashioned looking website. So that's the opposite of the fancy IIIF websites we saw from Kyoto and elsewhere. So this is 1995 style and hopefully going to be updated very soon with a new version, because the colleagues in the back end work already with the new versions. And here you do have lots of information on the text and the not in good Unicode but better code version typed fonts here and German translations. Right, and something else I'd like to show you, many colleagues knew the TLA, the Thesaurus Linguae Egyptiae, but what people do not know so far is the partner website of it. It's called Science in Ancient Egypt, and German and English website giving you lots of metadata from the Papyrus Ebers and all the other medical and magical papyri that people are working with. And you also have a huge bibliography. There's more than 300 titles now involved in it. And this is our colleague Lutz Popko, who has been working mainly on it and will update this website also as well. The papyrus collection of Leipzig University, where the Ebers papyrus is also stored, has also lots of more papyri, in total 4,500 sources, and they have something called the Papyrus Project. And this is not IIIF, so there's lots to do, but there you can also access the different class frames with the images of the stone. And now I'm coming back and share the screen again with the other resolution, going back to my presentation. So there we go. Yeah, so just to give you an idea of how these class frames look like, this is upstairs in the library, and we took this picture at 2017 when we did the Modic Congress in Leipzig, where Ikuyo Kato was also contributing a talk to. Yeah, so a couple of more information that the papyrus itself has also an interesting history, not going into detail here. It was found in Thebes, maybe between the leg of a Namami, who knows. Those informations are always highly doubtable. And there you have the facts one again. Once again about the sizes, that how old it is, that the date, and how many class frames there are. The Ebers papyrus is also famous because it has a calendar at the very last class frame, also the last part of the scroll, and there we know it's dated to the reign of Amenhotep the first, and particularly his 9th year, and there the rising of the Sotis star is mentioned. So this is a very important part in calendars, because this is when the Nile flood is coming. Yeah, what's in it? Actually, it's 879 texts. So we do have texts that we call sort of academic texts, Lehrtexte, prognosis, but mainly it's recipes, short form recipes. Some do have some more information, like explanations in this academic way, or magical incantations, or some texts are considered to be purely magical and not just magico-medical texts. But to give you an idea, for the recipes that are on the papyrus, there is always an incantation needed. So the medical specialist, mostly priests in Egypt, would need also the incantation, because, for instance, an unguent, a potion, a bandage is not working if you don't have the incantation to the gods. So this is very central to ancient Egyptian magico-magical belief. Yeah, here are all the links that I showed you, just for further reference, and a very expensive, but I guess very beautiful new book by Lutz Popko and his colleagues, which is also going to be released soon, when the showroom of the replica of the Ebers papyrus is going to be opened next week. Yeah, those are just, once again, the reference to the IIIF and the website. This was actually the starting point of renewing the whole website to be able to zoom in and to have the interoperable elements and so on. Just going over this briefly because this has been explained before, and you can also have a look at the showroom. So the remaining minutes, which are not that much, but I'm doing my best to finish in time, is devoted to what we did in South Africa when I was there teaching with my colleagues, Dr. Samantha Masters, who is a lecturer in ancient studies, and she's a specialist on Greek vases and Roman imagery. And then we joined forces and went to the Isiko Museum in order to not just to find out about the ancient artifacts that are not presented in public, but also to digitize a couple of them in order to teach the student how to create simple 3D models. Yeah, so we embedded this in a module called Ancient Cultures, Theory, Method, and Sources for honors students. Honors students means in their bachelor study course in the 4th year. Yeah, and this is modules that leave some space for critical thinking, to trying out stuff, to work in a project kind of way. And so we went to Cape Town from Stellenbosch, which is about 45 minutes. Hope the sound is better now. And they do have a place called the South African Cultural History Museum, formerly a slave lodge, which has a very sad history, as many of things in South Africa do. And slavery is also a very present phenomenon to the families, which is a thing where one could say a lot of things, but I leave it at that here. So this is the place where the Egyptian artifacts are stored, and they are mostly coming from colonial contexts. So British colonialists who brought their art of the ancient world, of ancient Egypt, Greece, and Rome with them. This is why a lot of these South African collections do have artifacts from the ancient Mediterranean. Those have been also, there were small rooms, and this is all now different and very interesting presentation. There's also apps where you can explore the ancient world, ancient Egypt especially. I've been contributing to the Cape Town School of Design when they created an immersive virtual reality environment. So very interesting things, and very much far off from what you see here, the class showroom with the grayish background. So we've come away from that. And in the Social History Center, which is another building adjacent from the so-called Slave Lodge, this is the part where they have the stacks, the magazine rooms. And this is where we went. People went there before, the colleagues. This is in the middle, this is my colleague Samantha Masters with 2 colleagues, among them Esther Esmiol from the museum. And this is Professor Cornelius, who is the doyen of ancient studies and Near Eastern studies in Cape Town and South Africa. So, and then we brought also Jessica Nitschke, another Egyptologist. She's originally from Philadelphia, and had first a look what we are going to do. And then we did the 3D modeling. So the students beforehand had to prepare about the objects. They were given publications, preliminary catalogs, so not much has been done in the collection, and there's nothing online so far. This is why the museum was very grateful that we come as a university in order to help them to digitize their artifacts, especially the ones which are not on display. And then the students were assigned a couple of objects and digitized them with different methods. Some people used the scanner from Nintendo Wii, so from the gaming engine. Some used their phones. Some had special good cameras. So the idea was also to compare the cameras that we were using for the 3D modeling, use different apps. iPhone has certain apps. Android has other apps, so we've been checking out this, and we also used material which is not easy to digitize, such as glass and gold in objects. So this is us once more. Those were the trial and error things we went through, and then we've been presenting these in a public event at the university. So not everything was easy to do. So especially with this Roman glass vessels used for unguents and oils, was not easy. It took a while for also to go through all the steps of the software. So this is once again the lessons learned that you have to assign, that you have to be aware that it takes a while, and especially those processes used took quite some time. And here it's so funny when the software is telling you it's 100% done and still something of the overall process missing. Yeah, so we embedded this also in talking about what 3D modeling is good for political events or the gaming industry, which is also for our students part of the job market. And we collaborated further with colleagues elsewhere. This man here on the bottom left part of the slide is Grant Parker. He is professor of ancient history at Stanford University, and Stanford University is especially famous for its digital collections, also using IIIF and doing everything nice and shiny. And there we do have accompanying to a very revolutionary book called South Africa, Greece and Rome, Part 1. Part 2 is in the making, which is working about all these colonial implication about cultural heritage and what meaning the ancient world has to South Africa, which is something I can't talk about here. This is a whole whole cosmos that's sometimes lost to classicists from the Northern Hemisphere. And we also created then these, at Stanford, these digital museums with it in IIIF. And this is where I leave it at. So those were 3 examples. Thank you for having a look. I'm stopping the screen sharing only to go back briefly once again to the browser to show you just where we have our 3D models. Those are stored on a portal called Sketchfab. This is sort of the YouTube for 3D models, and this is where we posted all these models. We had also replicas, cuneiform seal tablets. There is also something that's interesting in the contemporary history. This is a Greek vessel, but it is presenting the former president Zuma, who had a couple of scandals, and these scandals are envisioned also here in the depictions in this Greek way. This is done actually by students, or there is a fake of a Greek statue, which is part of a whole collection of fakes disseminated all over the world. Things that didn't work out so well, but also things that went quite nicely is terracotta figures and shaptis, a lotus cup. And some of these have already been printed out in 3D. So if you click on these, you can do much more and toggle and manipulate these things. But I'd like to leave it at this and stop my screen sharing. Thank you so much for listening so far, and I'm happy to take your questions.
Thank you so much for informative, very wonderful talk, Francisco. Yeah, we learned a lot, especially about, I learned a lot, especially about the visualization, fascinating and beautiful visualization of the digital Rosetta Stone project with Ugarit and also Papyrus Evers, and also your project at Itziko Museum, especially using photogrammetry and put it online, especially on Sketchfab. It is so amazing, and I think many people get interested in the ancient world with it. Thank you so much.
Thank you. Yeah, actually with the Sketchfab thing, I also did this in Leipzig before with students, and then I did this in South Africa, and then I was approached by Sketchfab. They do have a cultural heritage branch where, for instance, also the British Museum and other institutions are contributing 3D models. And then they were asking, can you write a blog entry? And my colleague and I, we then just wrote up what we were doing and why. Yeah, so it's used in cultural heritage imaging a lot by many countries, but also for teaching or just people who create, yeah, for gaming industries or also for private purposes, some 3D models. The purely digital ones are the photogrammetry as we did. Yeah. If something was too fast, I know I spoke very fast to show you everything. We can always have a look at things again.
Wonderful, thank you. Does anybody have any questions? Oh, especially Ishida-san, do you have any questions about the photogrammetry, also the, the visualization of philological information? No?
It's not very advanced what we did, because the idea was to try out what users who go into museums can do themselves with their phones today. So that's why we also wanted to keep it simple. So it's not state of the art. We had no laser scanners or something that you would use at what the colleagues are doing at excavation, or what the I see it here in Germany, where they have lots of federal museum agencies in the different federal states, and they of course have much more advanced technology. But I think it's important that the students know what they can actually do with their phones and what the visitors can do, because a lot of museums in the world are now encouraging their guests to come to the museum to take selfies, of course, because that's also an advertisement. We know that selfies on social media lead more people to come. And the same is true for 3D models. If people create them and put this in social media or share them on messengers. So this is interesting people, and it results in increased visitor numbers. It's now, of course, hard with the pandemic to follow this up, but some big museums like the British Museum and especially the Metropolitan Museum of Art in New York, who is very much on the forefront of the digital technologies and to invite bloggers. They have actually good numbers about this, and they said we have a peak in people watching others on Facebook, posing in front of a work of art. And this is creating some online traffic, but it also makes people to want to go and see the original, which is actually quite nice for us.
Yeah, also Metropolitan Museum of Art provides all the images with public domain. Is it common to provide all the images in public domain also in Germany or not?
It depends. Some do it, but many are still quite behind. So Germany is very interesting because it's different to many other countries. It has the 16 federal state. It's not a central state. This is the result of the Second World War, of course. So culturally, Germany is not a unity with a main national museum and everything else is branches of it, but you have something in Bavaria, you have the museum associations in Thuringia and elsewhere in Berlin. And some are more flexible than others. You have those smaller associations. For instance, in the small state in the middle of Germany of Thuringia, they are state of the art, or in Baden-Württemberg in the south, they are really good. We also in Saxony have quite some good ideas, whereas Berlin with those huge museum and these huge institutions is sometimes not as flexible and couldn't also react to current developments like those smaller city states or those smaller federal states can do. And if we look worldwide, we can see that the Metropolitan Museum and also the British Museum, who now have created a completely new website for their finds, are on the forefront. And also the Louvre just recently opened up their databases and make a lot of stuff available online and open source. Do IIIF, work with the communities and the developers. To my mind, that's the future, and that's also part of my job, to make everything as open as possible. Of course, there are rules, but basically we don't have obligations according to the law that they're still living people, because with sources from the ancient world, the people are dead since 2000 years or even longer. So you don't have any heirs who can claim any right. But then the houses have their own rules, and a house could say, I don't want you in, I don't want you to take photographs, I don't want my website to let you download things. So this is then the rules that the houses can impose. I've just learned recently at a conference that there is something like a database of lost art. I think I'm not naming this correctly, but this is in Brussels somewhere in Belgium, where people can actually refer to photographs that they have or works of art where they have no idea whoever produced that. You have all these museums who got donated photographs, historical images, artworks, and no one knows whoever was the creator, the author of these things. And you can register us with this registry of lost art. And yeah, but it's still a hassle to get this registered, but you have to try a lot of things beforehand before you are allowed to share it. Yeah, so this will definitely be issues that we will have in curating exhibitions, doing digital exhibitions and databases for a while.
Yeah, this the technology and also techniques of digital exhibition is more and more, I think, important.
Yeah,
especially not during the Corona time, but also after the Corona time. So yeah,
I know sometimes from museums when they don't know about creators, they just take an image and ask on Twitter, because sometimes to use the hive mind to have ideas, they can sometimes get to results, but sometimes you don't have a response whatsoever. So they just put it up on Twitter and say, does anybody know who created this artwork or who's the photographer of this photograph? Yeah, and sometimes you can have results, sometimes not.
This crowd, how should I say? I don't know, like in Japanese it is called sogochi, but crowd knowledge, crowd experts, very, very powerful.
Intelligence.
That's so auf Deutsch, yeah. Yeah, it is so powerful in these days, and it's Twitter, and people use SNS for knowledge they do not know, and somebody answer to her or him, and perhaps it is wrong, but perhaps it is true. I'm not sure, but it's pretty kind of very how should I say, global way. It's getting a global way to ask things, not to look at books or not go to library, but they ask people on the
and sometimes you get good results because there's lots of people, lay people interested in history and art. And another, since you mentioned Germany, another institution which is of course doing a lot of groundbreaking research are the Academies of Sciences. There are 8 ones, and they form a union in Germany. They are pretty unique institutions, and they actually have the time to do long-term research, which is otherwise usually in Germany not possible because it has a very unique university system where you only have short-term projects and short-term contracts for researchers. So the Academies of Sciences is actually where the groundbreaking and the hard work is done. Yeah.
I see. Oh, does anybody have any questions?
Yeah, and thanks again to Professor Nishioka for explaining everything about the AAAMF. I'm very grateful for that. Thank you so much. That was a great introduction.
Okay, so so you will also, you will also work on the IIIF in the future, right? With your project.
We were going to have projects where we're going to implement it for databases. Yeah.
Okay. Okay, so final remarks or questions, nobody? Okay.
I think it's already late in Japan.
Yeah, that's true. Yeah, that's 9 o'clock. So it's not so.
It's good to have everyone a nice evening and afternoon.
Yeah. So thank you so much, Francisca, for joining us. And thank you so much for giving your talk here. It's fascinating, and many people are also waiting for the videos who cannot attend this conference because they are in the United States or it's too late in Japan or something. But so thank you so much, Francisca, and thank you so much, everyone. Thank you so much, Nishioka-san. Thank you so much. And Professor Nedahoff, thank you so much, Morioka Sensei, and thank you so much, Carlos. Yeah, okay, yeah, thank you so much, everyone. Yeah, does anyone have any last remark or something? No. Kita Sensei, yeah, do you have something to say? No?
Nothing.
Okay.
So I enjoyed all talks today. Thank you for presenters.
Okay, so thank you so much, everyone. So this is a very long day. It was a very long day today because of some accidental schedule, but it's very nice day to learn so many things. Thank you so much, everyone. And next meeting is on the 23rd of October. About digital corpus and syntactic annotation through universal dependencies. Francisca mentioned UD on using Arethusa and also Ugarit and so on. But next in the next meeting we will have the talks about universal dependencies, especially for old Indo-European languages. For example, Kyoko Amano will talk about Vedic digital corpus, but not UD especially, but also kind of Vedic corpus in general. And the other two talks by Daniel Zeman and Giuseppe Cirano are on universal dependencies. And especially Daniel is kind of very expert who is very active on GitHub to update universal dependencies, and he is also one of the very chief members of the UD Pipe and Charles University Prague team. And Giuseppe Cirano is expert of universal dependencies, especially for Greek and Latin, and he's a chief investigator of the Arethusa project and also several projects in Leipzig, and he will talk about universal dependencies, potential and limitations. Okay, so thank you so much, everyone, for joining us for such a long time, and thank you so much, and good evening. Have a nice evening or have a nice day, or have a good night. Thank you so much, everyone. See you, and please join us again soon next week on Saturday. Thank you so much. ありがとうございました。Thank you so much.